Good morning, everyone. I hope my voice and video is clear to you. So, a very good morning to all of you. I hope you people have utilized yesterday in an effective manner. I hope you people have gone through the previous concepts, chapter number 6 and chapter number 7. So, I provided all the details, and I hope you have completed the chapter number 6 assignment also, so that you will be in touch with the concepts. So if you have been done, that's good, and if you have not done, that's up to you. So anyways, so I hope so you people have been completed the syllabus so far. So because apart from attending the online classes from your college and from ACE, there is no other work right now you are having. So you will be spending more time here with your family. So spend some time with your family, and remaining time you please prepare. Okay. So now there's a one small topic left over in the previous session, that is an Artesian condition. Okay. So in the previous session, we discussed about the capillarity, and I have solved a lot of the GATE and previous ESC questions. So now Artesian condition. So what is this Artesian condition, sir? So there comes now I'm going to discuss about the confined aquifer and unconfined aquifer. Confined aquifer and unconfined aquifer. See, the meaning of aquifer is water bearing strata. The meaning of the confined is water bearing strata. Yes. So the meaning of the aquifer is a water bearing strata. Aquifer, water bearing strata or permeable layer. This is known as a aquifer. See, water bearing strata means the soil mass where the water, groundwater is going to be stored. In the previous session, I told you how the gravitational water table is going to be formed. When the rainwater percolates into deeper layers and they starts to store over impermeable strata. So such a water is known as a water table, and that aquifer, that water table, whatever the soil mass is going to be the aquifer, water bearing strata or permeable layer. So now, what is mean by this Artesian condition, and what is mean by the confined aquifer or unconfined aquifer? Why we have to look over all these conditions? Now, let's see an example. Let's take this as a natural ground level. This is a natural ground level, Nana. So you know that the natural ground level is not going to be horizontal, but while we do analysis, we assume it as horizontals, but in reality, ground level will not be horizontal. So now, let's say this is some impermeable layer. Let's say this is a and this layer is clay layer, which is literally say, let's say, impermeable, because you know that the permeability of the clay soil mass is very less. When the permeability of the clay is going to be very less, we can assume it as impermeable also. So this is an impermeable clay layer, and there is a one more impermeable clay layer present again. Let's say there is one more impermeable clay layer. So this center is going to be clay. Let's say this is also going to be a clay. So now in between whatever I am going to show over here, this is also a clay. So this is going to be, let's say I am going to take it as a impermeable. Now whatever the soil mass I am showing you over here, this is going to be sand, and here also it is going to be, let's say it as a sand. Here also it is going to be, let's say, some other permeable soil mass or any other soil mass. So now you observe over here, this is a sand and this is a sand, this is a clay, impermeable. So now this is going to be permeable. This is going to be permeable. Generally, if there is a rainwater occurs over here, you observe, everybody have a look. If there is a rainwater occur over here, if rainwater occurs over here, this water will percolate, and as I said you, this is impermeable layer. The water will store over this impermeable layer. Let's say the water table over here. This is the water table, and mind it, the water table is also not going to be a horizontal water table over here. So this is the water table, let's say, where on this clay layer. You observe carefully, as I told you, the clay is impermeable. Do you think this water will penetrate below? No. But now you see what I am going to say here is, this is due to rain here. If rain occurs over here, then what happens? Then this entire water will infiltrate into which type of layer? Sand layer. You know, this entire is going to be, you know, again, what is this? This is an impermeable layer. This again, there is an impermeable layer. And you see, this is going to be the permeable layer. So now, due to rain, this water will starts to seeps or flow into the sandy layer. So now, if you observe carefully, slowly, the entire sand layer is going to be filled with the water. But if you see, and if you observe clearly, does this water will go upward? No. Does this water will go downward? No. Because here this sand is confined between two impermeable layers. The sand is confined between two impermeable layers. So whatever the water that comes through the rain will get stored in this sandy layer, and slowly the water table in the sand layer will rises to higher level, and it can rises to the ground level also. I'm telling you. So whatever the water coming from the rain will get stored in the sandy layer or permeable layer present between the clay and clay. See, this is going to be the water bearing strata. This is a water bearing strata, and it is going to be present between two impermeable layers or not? Yes or no? So as it is going to be present between two impermeable layers, can I call this is an aquifer which is confined on top and bottom? Now we are going to say this one as here, this one as confined aquifer, and this is also known as a artesian aquifer. Artesian aquifer. So what is the meaning of the confined or artesian aquifer? Artesian aquifer, if a water table or water bearing strata, if a water bearing strata is present between two impermeable strata, then we are going to say it as a artesian aquifer. So now I am going to tell you, see, whatever this is nothing but this is going to be a clay, right? You know, this is going to be the clay. Whatever the soil mass, this is going to be clay. Again, this is going to be impermeable. So if a sandy layer, which is nothing but permeable layer, present between two impermeable layers, then the resultant condition is known as a confined aquifer. Such a aquifer is known as artesian aquifer. Sir, what about this one, sir? Sir, you see, this is also going to be water bearing strata or not? Yes or no? But here, this water is going to be confined at bottom and free at the top. So if any one of the either top or bottom is free from confinement, we are going to call it as unconfined aquifer. So this is going to be unconfined aquifer. This is going to be unconfined aquifer. So I hope you understood the meaning of this confined aquifer and unconfined aquifer. So what is confined aquifer? Whatever the water bearing strata, this is a water bearing strata present between the two impermeable strata, and whatever the water bearing strata present above the impermeable strata and below the ground level, this is known as unconfined aquifer, and this is going to be the confined aquifer or artesian condition. So now what happens over here? Everybody observe, when this water is going to be travel, this water will be moving from now. You see, this water will tries to move in upward direction or not? Yes. Because you can observe there is a difference between the water level. You can observe there is a difference between the water level. So now, if I insert a piezometer, you see, due to confinement, the water pressure in the artesian aquifer is very high. Due to confinement, water pressure in artesian aquifer is very high and tries to move upward. See, when it tries to move upward, but this is a clay layer which is impermeable, which means its permeability is very less. When the permeability is going to be very less, it will allow very less amount of the moisture. So now what happens over here is, so if I insert a piezometer over here, observe. So If I insert a piezometer over here, do you think, now the question is, do you think the water level will rise? See, so far and so good, I told you, Arre Baba, when you insert a piezometer or a well, the water level will rise up to the water table. Yes or no? But now you observe, I am inserting a piezometers. One is on the confined aquifer and other is on the unconfined, sorry. Yes. See, I have inserted two bore wells. Yes. I have inserted two bore wells. I hope everybody able to understand over here. I have inserted two bore wells over here. So now, if you see, out of these two bore wells, one is this bore well I have inserted in which layer? Unconfined aquifer. So in the case of the unconfined aquifer, the water pressure is normal. The water pressure is normal. So now in this case, the water level will rise exactly up to the groundwater table only. Okay. The water level will rise up to the exactly groundwater table only. But in the case of the confined aquifer, as this aquifer is present between two impermeable layers and the water does not have any scope to escape. So the pressure in the water in confined aquifer is going to be more. Come on, you please tell me, what is the water table of the confined aquifer? This is the water table of the confined aquifer. What is the water table of unconfined aquifer? This is the water table of the unconfined aquifer. Now, in the case of the unconfined aquifer, sorry, confined aquifer, water level will rises not only this water table, but above this one. Now, this water starts to spills out. Sir, up to what height this water is going to be spills out, sir? You see this level, sir? So whatever this line is nothing but the hydraulic gradient line or piezometric surface. Piezometric surface. And this water rises above this point. If you observe, whatever this water, this will rises up to this height. So such a type of wells are known as artesian wells. So this well is known as artesian well. And whatever the height up to which the water level rises in the artesian well is known as artesian head. So now you see you observe, if I would have kept a piezometer over here, if I would have kept the piezometer over here, this water level will rise up to whom? This water level will rise up to the unconfined aquifer only. This is a pressure head. Okay. Now, whatever the height up to which this water level rises, from here to here, or you observe now, whatever the rise, this is the rise up to which the water level is going to be rises. Now, this is known as HA, where HA is known as artesian head. So what is artesian head, sir? Artesian head means water level that rises in artesian well. In artesian well. So now I hope you understood the basic difference. See, I have inserted two piezometers or two bore wells, but in this bore well, the water table is rising up to water table only. Yes or no? The piezometer water level rise up to the water table only. Why? This is unconfined aquifer. So far, so good. Whatever the discussion we made is unconfined aquifer. But wherever you see, I'm telling you, you please remember this point. Wherever you see, there is a, now, wherever you see, there is a water-bearing strata present between two impermeable strata. Water-bearing strata present between two impermeable strata, which means there is a sand layer and below clay, above clay, below rock, above clay. Such a type of conditions are known as Artesian condition. Now, in the case of Artesian condition, when you insert a bore well into the confined aquifer, now the water level in the bore well will rise up to its piezometric surface. What is the piezometric surface? This is the water table level R0. So this is known as a piezometric surface. So similarly, the same thing, if you insert a piezometer here also, it will rise up to the same point. So now this well is known as the Artesian condition. See, if now I'm asking you, okay, you see, if the head is going to be HC, then pore water means capillary pressure is going to be gamma W into HC. If the head is going to be seepage head, then seepage pressure is equal to gamma W into H. If the head is going to be pressure head, then pore water pressure is going to be gamma W into HP. Yes? Now, if the head is going to be Artesian head, then what is the Artesian pressure? See, now my question is, with the water pressure, this is going to be rises. So definitely there exists a pressure over here or not? Now, this pressure existing on the clay layer is known as Artesian pressure. What is this? Artesian pressure. So where the A is going to be Artesian pressure, and when it is Artesian pressure, gamma W into HA. See, if I say pore water pressure, that is going to be gamma W into HP. If I say Artesian pressure, that is going to be gamma W into HE. See here, there is no difference between the Artesian and pore water pressure, but only small difference is, so pressure head is going to be seen in the case of unconfined aquifer. Artesian head can be seen in the case of the confined aquifer. That is what my major point of discussion over here. So I can write over here, pressure head, unconfined aquifer, Artesian head, confined aquifer. So that's it. If you understand these points, so now, due to confinement, water pressure in the Artesian aquifer is very high and tries to move upward. So whatever this well is known as Artesian well, and this head is going to be the Artesian head. That's all. Please go through this figure. I explained everything in the figure only. So whatever these points, so that is just you don't need to go too much. What you need to know is, okay, if a permeable strata present between two impermeable strata, kya hota? Then in that well, the water level will rise as corresponding to the confined aquifer water table, not the unconfined aquifer water table. This is unconfined aquifer. This is a confined aquifer. Can impermeable layer also be also rock also? Yes, it can be. Sir, why is hydraulic gradient in horizontal, sir? Because see, a very good question asked by one of our student. Here, if you observe, see, this is a clay layer, right? Actually, in fact, to say, In reality, the piezometric surface a little bit falling. You observe whatever the slope it is going to be fall, it is very, very, very less slope. The slope is going to be very, very less, which means the head loss is going to be very, very, very less. I can say, see, in reality, the hydraulic gradient line is almost horizontal, but it's going to be a little bit inclined. A small amount of, see, this is the upward seepage, right? Here there is a seepage. And from here to here, when it rises, then definitely the head loss is going to be there. So which is very, 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 very less, but we can neglect that head loss in reality. So now, this is the artesian well. That's what, see, some of the students are asking, sir, one of our students, sir, in this artesian condition, what is moving from one end to other? Then this becomes hydrodynamic condition. And due to this, head loss is not occurring as artesian head. You took up to initial head. See, the point over here is this is impermeable. Yes. When it is going to be impermeable, does this water enters into the clay layer? No. If it enters, then there is a head loss. Understood? So, but this is going to be an upward pressure, and with what pressure it is going to be clear from this much to this much. This is the head which is going to be required to cause this pressure. That is the reason why water level in the artesian well will rises up to the piezometric surface. Springs are example of artesian well. Yes, very good. Springs, natural springs. So you can see the springs means the outcome of water above the ground level also. That is nothing but artesian well. So that's all with this. Sir, there will be natural groundwater table in unconfined aquifer. Yes. Whatever this is natural water table, this is groundwater table, Nana. Unconfined aquifer means groundwater table. Okay. This is a groundwater table. Sir, artesian pressure cannot be negative. It cannot be negative. It cannot be negative. Sir, when impermeable layer is replaced with rock, at what height artesian head will rise? Whatever it is clay, whether see where I am inserting the artesian well. Am I inserting in a permeable layer or impermeable layer? Permeable layer. So here, in the case of confined aquifer, the point that you need to look over here is, I am telling you again and again and again. Please listen to this. If you insert a well or bore well, in the case of the confined aquifer, the water level in the well will rises up to the confined water table. This is a water table. So if you insert the bore well, in the unconfined aquifer, the water level will rise up to the unconfined groundwater table. So confined piezometer, confined water table. Unconfined piezometer, unconfined water table. Sir, if the clay is impermeable, how long it takes the water moves to sand? At the same time, water in the sand layer will try to move upward and downward. If the clay is impermeable, how come the water move upward or downward? Sir, seepage loss we are not considering. Why you see people, you please observe. I am drawing this hydraulic gradient line as an inclined one only. This is not horizontal. This is not horizontal. Don't think this is a horizontal. This is a inclined. So when it moves, the loss. This is a permeable layer. The loss is going to be less. From here onwards, the flow is going to be happen. This is upward. Up to this point, this is a just a normal seeping of flow under the gravity. from here to here, head loss is very, very less. If they give the head loss, you have to take it. See, this piezometric surface is not horizontal. It's not a horizontal line. I am drawing, this is not a horizontal line. See the meaning of horizontal, I'll show you here. This is a horizontal, Nana. Okay, this is a horizontal, but I did not draw it as a horizontal. I am drawing some little bit inclination should be there. You see, observe this one. This is a horizontal, this is an inclination. Then whatever the difference is nothing but a head loss or not. After all discussing the same questions, how come we know that the head is artesian or pressure head? Right, Baba, I'm saying the point, if the well is going to be in the case of confined aquifer, so I'll write this point also. Note, if well is dug into confined aquifer, if the well is dug into confined aquifer, then water level rise is artesian head and well is artesian well. Now, if well or borehole is dug into unconfined aquifer, then water level rise is pressure head. Water level rise is pressure head. So, and artesian head is more than pressure head due to pressure in a permeable layer between two impermeable layers. So the conclusions I want to say here is, you please stop your questions. The conclusions I want to say here is, wherever there is a two impermeable layers, if in between there is a sand or permeable layer, then such type of condition is a confined aquifer or artesian aquifer. So in the case of the artesian aquifer, the water pressure is going to be more. When the water pressure is going to be more, then the artesian aquifer is going to be then the water starts to move upward. Such a pressure exerting is known as artesian pressure. So how much pressure it exerts over here, sir? If you insert a bore well, the water level will rise up over here. So it is also nothing but a spring. So such a head is known as an artesian head, and such a pressure is known as artesian pressure. PA is equals to gamma W into HA. That's it. You don't need to go beyond these points. So again, sir, still what level does the artesian well spills out? You see, this is nothing but the piezometric surface. Up to piezometric surface, the water level will spills out up to piezometric surface. अरे बाबा, Artesian pressure acts against gravity, so it is negative. अरे क्या रे भाई, Artesian pressure is not rising against gravity रे भैया. That is due to pressure movement. It's not due to the capillarity. Capillarity is due to surface tension. Capillarity is due to surface tension. Here, due to pressure difference, the water is moving up. It is not negative. Sir, is capillary possible? No, here, see, the capillarity, they will say, Nana, why you are worrying about that? The capillarity can be seen in the case of fine sands and silts, right? Fine sands and silts. If I would have mentioned this as a fine sand in unconfirmed aquifer, then there is a possibility. Okay, fine. Now, let's go with one question. So groundwater table in unconfirmed aquifer should be a straight line. Nana, groundwater table in reality it will never has a straight line. For our assumption, we take it as a straight line only. So in reality, groundwater table or ground level are not going to be a straight lines. There is a small difference between the. I don't know some of the students, sir. In reality, how to find this confined and unconfined layers, sir? ये क्या रे भाई, आपको दिमाग है or not? How many times I said you? This is nothing but a impermeable. This is a impermeable. If a permeable sand, by doing soil exploration, by conducting the soil exploration, if you know a sandy layer present between two clay layers or a clay and rock layer, then it is going to be confined aquifer. Now that's all with your questions. So I'm not going to answer any questions now. So it's already I have done a lot of things. The concept is very little. I said only 2 points, and in these 2 points, you are getting 30 questions. Yes. Now let's see the problem according to this one. What is that? A minute. Now, you please, I hope everybody have done their questions. Okay, I have asked you to solve the question number 7 and 8. I hope you people have done it. Now, I'll explain the logic. I'm not going to solve it. So the people who have done, I'm going to explain the logic. Just simply. So, a layer of the saturated clay, 5 meters thick is overlain by sand. A layer of the saturated clay is 5 meters thick overlain by sand. The water table is 3 meters below the top surface. Saturated weight of the clay and sand are given, and the unit weight of sand they have given. This is gamma W. You see, this is overlain. What is the meaning of overlain? A layer of saturated clay overlain by sand. So above there is a sand, below there is a clay. Underlined by sand. Underline means above clay, below there is a sand. So this is nothing but overline over here. I have asked you to solve this question. I hope everybody have solved this question. Now the last question in this chapter is this question number 9 and 10. Have a look. A soil profile consists of a surface layer of clay. So they have given surface layer clay 4 meters. Its unit weight gamma 19.5. And sand layer 2 and its unit weight 18.5. Overlying an impermeable rock. Overlying on an impermeable rock. Clay, sand, rock. which means sand is a present between two impermeable layers or not. One is clay, other is rock. Now, the people who are asking, sir, how come I fix this is the confined or unconfined? You please tell me, is it going to be confined or unconfined now? Confined aquifer, which means definitely there is an artesian condition. And the water table is at a ground surface. If the water level in the standpipe driven into the sand layer 2 meters above the ground surface, 2 meters above the ground surface, take gamma W as a 10. What is effective stress at a depth of 6 meters? And the increase in effective stress at the top of rock when the artesian head in the sand is reduced by 1 meter will be. So, please give me a minute. I forgot to bring my water. So please give me a minute. I will bring my. Okay. So now I'm back. Fine. So now this is the question I'm asking you. Let's see how to solve this. This is question number 9 and 10. So, classroom practice questions. Question number 9 and 10. Now, whatever the data they have represented, please draw it. This is a ground level. This is a ground level. And on the top layer, there is a clay which is going to be 4 meters. 4 meters of clay is there. And then below 2 meters of sand is there. And then there is a rock. And then there is a rock. So now you see this is a ground level. And whatever the soil mass here is a clay whose unit weight is going to be 19.5 kilonewton per meter cube. And here it is going to be sand whose unit weight is going to be 18.5 kilonewton per meter cube. So now what they mentioned is if water table is at ground level, water table ground level means this gamma becomes gamma sand. So whatever the unit weights they have given is a gamma sand. So now you see this is going to be rock. So sand is a permeable layer present between two impermeable layers. So now you tell me, does this sand is going to be a confined aquifer or unconfined aquifer? This is a confined aquifer. So sand present between two clay and rock acts as artesian aquifer. So now you know that in the case of the artesian aquifer, if we insert a piezometer or a borehole, see they mentioned a standpipe. They mentioned a standpipe like this. This is nothing but a standpipe or a piezometer. This is a standpipe. So now you see you have inserted in the case of the standpipe. So what is the effective stress? There is a question now? Yes. Where I am asking you, what is the effective stress at a depth of 6 meters in kilopascals? At a depth of 6 meters in kilopascals. You know, the clay layer is 4 meters, sand layer is 2 meters. Now, I want the effective stress at the 6 meters depth. So, in the piezometer or standpipe, water level rises 2 meters above the water table. What is the meaning of this 2 meter rise above the water table? Which means the artesian, see, you observe, this is going to be a clay and here it is going to be a sand. You see, and coming to the example, wherever I kept over here in the permeable layer, if the permeable layer, if I insert a piezometer anywhere over here, then the water level will rise up to whom? Corresponding water table, not to this water table. This will rise up to this water table. So they mentioned it clearly already. The water level in the standpipe rises 2 meters above, which means there is a difference in the water levels. And due to this difference, definitely water will flow from the sand to the clay layer. If the clay permeability is very less, then the seepage is also going to be very less. I hope you understood the meaning over here. So now, can you please tell me what is effective stress here? So what is effective stress at 6 meters? Total stress minus pore water pressure. Yes or no? But now it is no more a pore water pressure. What is this? This is an artesian pressure. What is the pressure? It is nothing but an artesian pressure. So you see, this is going to be 2 meters. Then whatever the rise we are going to get over here, this is known as artesian head. So now let's find out the total stress and artesian pressure. First of all, what is the artesian pressure? Gamma W into HA. So gamma W is given as 10 into HA, 2 plus 4 plus 2, which is going to be 80 kilopascals. This is artesian pressure. And what about total stress? Directly let me write down the effective stress. Effective stress means total stress. What is the total stress? Keep your palm. Gamma sat of clay into 4 plus gamma sat of sand into 2 minus 80, which is going to be 19.5 into 4 plus 18.5 into 2 minus 80, which is going to be 35 kilopascals. So this is the answer. That's it. Instead of pore water pressure, now I'm taking it as artesian pressure, because you know that if, see, I write over here, you know that if it is going to be confined aquifer, then artesian head. If it is an unconfined aquifer, then pressure head. Whatever the pressure corresponding to pore water pressure head is pore water pressure. Whatever the pressure corresponding to artesian head is artesian pressure. So if it is unconfined, then I use pore water pressure. If it is a confined, I use artesian pressure. I hope you understood the difference between these two. Now, if artesian head falls by 1 meter. So, given question, they have given if artesian head falls by 1 meter, then what is a delta HA minus 1 meter, which means a fall. Now, what they're asking is a change in the effective stress. Okay. You know that effective stress is nothing but total stress minus pore water pressure. But as it is a confined aquifer, I am going to write this one as a artesian pressure. So change in effective stress is equals to change in total stress minus change in artesian pressure. Change in artesian pressure. Okay. So now you please tell me, is there any change in the unit weight of the soil? Is there any change in the unit weight of the soil? Come on, everybody, I'm asking you, See, as there is no change in the unit weight of the soils, then the total stress remains same or not? You see, meanwhile, as there is no change in the unit weight of the soil mass, the water level in the piezometer falls by 1 meter, which means this is going to be delta HE. So from this to this point, the water level falls by how many meters? The water level falls by 1 meter. But is there any change in the unit weight of the soil? As there is no change in the unit weight of the soil, now this is the logic I am discussing over here. As there is no change in unit weight of soil. I hope these logics have been explained clearly in the previous gate also. You please go back. When there is no change in the unit weight of the soil, then change in total stress is equals to 0. Then change in effective stress is equals to minus change in artesian pressure or pore water pressure. So minus gamma W into delta HA minus 10 into delta HA is minus 1. So delta sigma dash is equals to 10 kilopascals. The people who have understood the logics in the earlier, they can solve it very easily, because as there is no change in the unit weight by fall of artesian head, no change in the unit weight, then the delta sigma to change in the total stress is going to be 0. Sir, I don't want to go like this one, sir. Sir, I will go with the basic, sir. So let's see the basic also, sir. The basic method is, if artesian head falls by 1 meter, then net HA is going to be 7 meters. Then net HA is going to be 7 meters, because 4 plus 2 plus this is going to be 1 meter, right? So now at this case, the effective stress is equals to total stress minus artesian pressure. What is the total stress saying? 19.5 into 4 plus 18.5 into 2 minus 10 into 7, which is going to be 45 kilopascal. Then the change in effective stress is equals to final 45 minus initial, which is going to be 10 kilopascals. So I hope you understood. I'm using the small logics over here. The logics are, as there is no change in the unit weight of the soil, there is no change in the artesian head. So if you remember, I have used the same logics in the previous IS gate questions. So I'll show you those questions also as a moment. See, these are the things that we have been discussing in our earlier classes, right? Yes, you please look over here. I hope everybody, this is one of the previous gate question. In top 5 meters, if soil is changed, unit weight remains same. Yes. So you please look over this point. As there is no change in the unit weight, then change in total stress is 0. And change in effective stress is equals to minus change in pore water pressure, which means magnitudes are same, but signs are different. If pore water pressure decreases, effective stress increases. So this is what I want you to conclude over here. That's all. So I hope you understood this logic also. So some of the students were asking, what is the answer of 8, sir? Sir, you please tell me what will be the increase in effective pressure at 9 meters if soil gets saturated by capillarity up to height of 1 meter. You please see, I'm giving you one more time the hint over here, those who did not go through this question. So you please see, this is a layer, above this is a sand, and below this is going to be clay layer. So they mentioned that initially, for the question number 7 and 8, Nana, for the question number 7 and 8, the water table is 3 meters below. The total depth of sand is going to be 4 meters and the total depth of the clay is going to be 5 meters. Initially, water table is going to be 3 meters below. It is going to be 3 meters below. So now, what they're asking is, the saturated unit weight of the clay and sand are 18 and 20, whereas the unit weight of sand, above this is going to be 17, below this is going to be 20. Now, the question number 8 is, what will be the increase in effective stress at a depth of 9 meters? At 9 meters means delta sigma dash 9 meters. This is the question they're asking. I told you the logics over here. What is the logic I mentioned? The logic I mentioned is, below water table, this is capillarity up to what height? 1 meter. Below water table, at any depth. See, this is a water table, right? This is a water table. 9 meters is a below water table. At any depth, change in pore water pressure is going to be 0. Then change in effective stress is nothing but change in total stress. Initially, in this 1 meter, gamma, final gamma sat into 1. So 20 minus 17 into 1, the answer is going to be 3 kilopascals. Just, it's going to be directly, I don't say all these things, Nana. If you understand the logic over here, then 20 minus 17 into HC into 1, the answer is going to be 3 kilopascals for this one. I hope everybody have understood these logics. The logics are really, really important. But 0 is not an option. Who said answer is 0? It's not 0. The answer is 3 kilopascals, okay? The answer is going to be 3 kilopascals. So the answer is A. Answer is going to be A, 3 kilopascals. If you want to go for that, you can see this point also. So I mentioned that point clearly over here. You see, this is the logic. This is the logic. You please go through this one. At any depth below water table, due to capillarity, change in pore water pressure is 0. So change in effective stress is equals to change in total stress. Now, that's all with this chapter. So what I have discussed today is the Artesian condition, and we have solved a problem regarding to the Artesian condition, because this Artesian condition will be there. You are going to see this Artesian condition later also. So what I want you to people know is, don't worry about the Artesian or pressure head. Both are same, but this is going to means both are same in the sense of means both are water pressures. So, but one is going to be for confined aquifer and other is for the unconfined aquifer. That's the difference. That's it. Now, let's start new chapter. In this chapter, we are not going to learn anything new, because I have introduced already everything. Chapter number 8, seepage pressure. Look, you see, in chapter number 6, I'm just writing as a point over here. I'll be erasing it later, but in chapter number 6. In chapter number 6, what I have been discussed with you is seepage. In chapter number 6, I discussed with you seepage, and in that seepage, how to find out the hydraulic gradient, which is nothing but H by L, where H is hydraulic head or head loss, hydraulic head or head loss, and L is seepage length. Then how to determine the head loss at any section? I into length up to X. How to determine the pressure head by means of this head loss. You can see the total height minus head loss up to x, and then we discussed about the discharge. Q is equals to ER. This is the things that we have learned. In chapter number 6, I explained you the seepage conditions clearly. In chapter number 7, mostly I discussed the hydrostatic condition. Yes or no? What is the hydrostatic? No flow. So this is a seepage flow condition. This is a hydrostatic no flow condition. And in the case of the no flow condition, then how to determine the effective stress, which is nothing but total stress minus pore water pressure. So in chapter number 6, our main focus was to find out the I, and then to find out the head loss, and then to find out the pressure head. So now when there is no flow, then you know that pressure head, water level will rise up to the corresponding water table. Now I am going to incorporate chapter number 6 seepage and chapter number 7 effective stress into chapter number 8 seepage pressure. Without knowing this, you have done already one problem. Without knowing all these things also, we have done already one problem. So let me show that problem also. Yes. I hope you have remembered this question. You see, this was a question that I have given in a GATE, means in GATE, but you have seen this question in an effective stress topic, right? But if you observe clearly here, now you see this question. This is a question combination of effective stress plus seepage, right? Which means chapter number 6 and chapter number 7. So this is a effective stress, finding the effective stress, and you know it very clearly. In order to find out the effective stress, you require the pressure head. For finding the pressure head, we have been all these things. So when there is a flow, then how to determine the pressure head? H, L, hydraulic gradient, head loss up to Q, and then effective stress. Without knowing the things, already we have done the problem. Now, my point is to make you sure understand what is the logics behind this. And what are the different type of seepage we are going to see. See, this is the type of problem, but now I am going to discuss it in a theoretical way, in a conceptual way. This is just a procedure, but I am going to discuss in conceptual now. So let's have a look. Okay. So for the explanation of this one, let me take at first hydrostatic condition, whatever the condition we know so far. Hydrostatic condition, and we call this condition as a no flow. What is the meaning of hydrostatic condition? No flow condition. So for that, now I am going to take an experimental setup. So let's see that experimental setup. How does it looks like? Let's take this as a mold, and this mold is filled with the soil mass. This mold is filled with the soil mass, and on the top of this mold, I'm going to provide a water table on the top of the mold. I'm going to provide a water table. See, this is a water table and this is water, and at the bottom there is a tap, and at the bottom there is a tap. Initially tap is closed. Initially tap is closed. See, what I am doing is I took a mold. I am preparing this in an experimental setup. So what I have done is, at first I take a mold and then I fill the soil mass with I fill the mold with the soil, and slowly the soil is going to be fully saturated. Slowly the soil is going to be fully saturated, and I kept a water table above the soil. See, does this condition is exactly similar to lake water body or any water body, right? Does this condition, see, if I say this is a bed level, if I say this is a bed level and this is a soil mass below the bed level and this is the water above the bed level, whatever the water above bed level is nothing but water body. Can I represent this one as a lake or river or marine? And now my point is, if the thickness of water is going to be HW, if the thickness of the water is going to be HW, okay, yes. So whatever the thickness of water, let's take the thickness of water as HW, means height of water, and the thickness of the soil mass as Z. Thickness of the water as HW and thickness of the soil mass as Z. And you know it very clear that the unit weight of the water is gamma W and unit weight of the soil is going to be gamma sat. So for this condition, now initially I close the tap. When I close the tap, is there any flow of the water? No. Such type of condition is known as a hydrostatic condition. So now at this point A, everybody, can you please tell me what is the total stress, pore water pressure and effective stress? Now, come on, please tell me. At A means, tell me means here, you please, you can write on your notes or whatever the paper you are having, unmute it. What is the total stress at A? At A, see, I am representing A over here. At A, what is the total stress, please? Whatever the unit weight above, whatever the unit weight above into its depth, whatever the unit weight above into its depth, which means gamma W HW plus gamma sat into Z. I hope you understood the meaning over here. Gamma W HW plus gamma sat into Z. So similarly, what about the pore water pressure? Gamma W into HP. How to find out the pore water pressure? So how to find out the pore water pressure? You know that pore water pressure can be measured by inserting a piezometer. So now let's see. This is a piezometer. So now you observe this is a piezometer, and when I say this is a piezometer, then as there is no fall off, see, when there is no flow, then there is no head loss, and when there is no head loss, then there is no fall of water level. From the starting of this chapter number 6 and 7, I was saying the same point. So no fall of water level in the piezometer, then the water level will rise us up to the corresponding water table. So what is the pressure head now? The pressure head is going to be gamma W, sorry, HW plus Z. So from this I can write U is equals to gamma W into HW plus Z. Then what is effective stress here? Effective stress means total stress minus pore water pressure. So effective stress is equals to, you see, gamma WHW, gamma WHW gets cancelled down or not? Yes. Gamma WHW gets cancelled down. Gamma sat into Z minus gamma W into Z, which is going to be gamma dash into Z. You know that clearly in the previous chapters also, whatever the soil mass below the water bodies, whatever the soil mass, have you remember one logic? Below the lake water bed, below bed level, whatever the water above the bed level does not affect any effective stresses, because array isme koi means in this water there is no solids. When there is no solids, there is no effective stress. So can you see any expression of HW in effective stress? No. Whether the HW is 1 meter or 2 meter or 3 meter or n meters, it does not cause any change. So effective stress is simply gamma dash into Z. I can write it directly. How? By apply logic. What is the logic, sir? Array, sir, this water does not affect any effective stress, sir. Below that, soil is completely saturated and submerged, sir. When it's effective stress, sir, sigma dash, sir. Sigma dash, sir, gamma dash, sir. If I ask sigma, gamma, sir. I gave you these conclusions clearly in the previous chapters. Okay. So now, I have some of this. Okay. Now, I hope everybody understood this condition. These things we have been discussed so far. But let's see what happens if we insert a CPACE. So now I want the CPACE. What happens if I open the tap? What happens if I open the tap? If I open that tap, you observe the difference. I'm going to take the same thing, and mind it, you are going to supply the water continuously. You're going to supply the water continuously, so that you need to make sure this height of water is a HW. So now if I open the tap, what happens? If I open the tap, then the water will fall from up to the down through the soil mass. Then the seepage is going to be happen or not? Such a type of seepage is known as downward seepage. Now I am going to discuss the next thing, downward seepage. Downward seepage. Sir, how we are going to explain this one, sir? This downward seepage, I'll take the same example. You see. I'll take the similar type of the soil. Now at first you fill this with the soil, and then you insert the water table. You insert the water table of same height, HW. So this is a water, and this soil is going to be completely filled with water now. But what is the difference I am going to do here is, first let me represent all these things first. You know, this is the height of water, and you know this is the thickness of the soil. So whatever the height of water, this is HW, and whatever the thickness of the soil, this is a Z. So now at the bottom, if I open the tap is open. Here tap closed, and here tap is going to be open. When I open the tap, definitely the water will start to move on. See, when I open the tap, then I have allowed a medium to pass over here, then the water starts to travel. Already soil is fully saturated on, and you have to supply the water. Keep that in your mind. You have to supply the water in such a way this water level should remain constant. So now this water starts to move downward. So can I say, is it a downward seepage or upward seepage now? This is going to be a downward seepage because the flow starts to move downward direction. And then what I do is I keep a beaker. Yes. So when I keep a beaker, then definitely I can fill this with the water or not? Yes. Now you can fill this beaker with the water. So now you tell me, please. See, is it a downward seepage or upward seepage? I have discussed this type of situations in chapter number 6 itself. I hope everybody is able to solve this type of questions because these are really very important questions in the case of chapter number 6, 7, 8 and 9. So this is the basic difference between the hydrostatic condition and downward seepage is this is a tap closed and now I open the tap. When we open the tap, the flow will be taking place from 1 to 2. When the flow is going to be takes place from 1 to 2, you know that flow always takes place from higher water table to lower water table. Now, you are going to start with a head of H. You are going to start with a head of H. Now, as you move downward, my question for you. As you move downward, Are Baba, this water is you. Make sure yourself. I am giving you that you have energy of some 5 meters. Now, as you travel, when you travel, are you going to lose your energy or gain your energy or remains constant? When you travel, definitely you lose your energy. And by the time you reach over here, let's say 50% of your energy lost, 0.5 H. And by the time you reach over here, 70% of your energy lost. And by the time you reach over here, 100% of energy is going to be lost. Which means by the time you reach over here, what is the head you have? 0. What is the last you got? H. So I start with H and by doing all the work along Z, I lost that H. So whatever the difference between the water levels, now I want to show here, whatever the difference between the water levels, this difference between the water levels is known as a H, where H is known as a hydraulic head or seepage head. Hydraulic head or seepage head. So hydraulic head, yet start of flow or head loss at end of flow. What is the meaning of a hydraulic head at start of flow, sir? Sir, what is the mean by hydraulic head, sir? Hydraulic head means the minimum energy required to cause the flow. So this is the minimum energy required to cause the flow. What is that minimum energy? Hydraulic head, which means it's starting of the flow. And what is mean by head loss? The head that's water loss by traveling, which means when you are going to say the head loss after doing the entire work or not? Yes. So when I say head loss, that is at the end of flow. When I say hydraulic head, that is at starting of the flow. So now this is a total head loss, a total hydraulic head. So I don't need to write over here because you know all those things. Now coming to the same point, I want to find out the stresses at point A again. Everybody, come on, tell me. At A, same point. This is now the conclusions are going to be seen for you. At same point, what is the total stress? What is the total stress, please? Come on, tell me. The total stress at this point. See, does the unit weight of the soil changes? What is unit weight over here? Gamma sat. What is unit weight over here? Gamma W. So, now gamma sat, gamma W. So now what is the total stress over here? Is there any change in the unit weight? No. Is there any change in the depth? No. Total stress, whatever it is, Artesian condition, capillarity, Artesian condition, you take any condition, total stress, wherever you want to find, above that point, whatever the unit weight into corresponding depth. The unit weight here is gamma W, corresponding depth is HW, plus the unit weight here is gamma sat, corresponding depth is Z. So now coming to the pore water pressure, gamma W into HP. So how to determine the HP? Again, we have to insert whom? Piezometer. So now this is a piezometer. So come on, you please tell me. Now do you think the water level will rise us up to piezometer? You see, this is the initial water level, right? This is the initial water level. Observe, please, while you're seeing, you see the both the figures. I have shown you this one. See, in this case, when there is no flow, there is no head loss. When there is no head loss, water level rises up to the corresponding water table. But you see here, as a flow takes place from 1 to 2, by the time it moves, then slowly the water level in the piezometer falls. And this is a starting point and this is the ending point. When it is ending point, you know that the water level will rise corresponding to the water table. This is the ending water table. So what is the pressure head over here? This is going to be the pressure head. I hope you people understood this pressure head. So you see here, this is a pressure head and here this is the pressure head. What happens to pressure head due to downward seepage? The pressure head, which means the water level in the piezometer has been lowered down or not. So now let's see. Let's see. So what is HP over here, please? Tell me. Then if that is the case, what is HP over here? Please tell me. What is this HP? This HP can be written as total HW plus Z. HW plus Z total minus C. What is this pressure head you observe? HW plus Z. But compared to this HP, this water level has been fallen down by how much? The water level has been fallen down by how much? H. So minus H. Then pore water pressure U is equals to gamma W HW plus gamma W into Z minus gamma W into H. Now everybody tell me what is effective stress. What is effective stress, please? Here everyone have a look. What is effective stress here? Effective stress is equals to gamma W HW minus gamma W HW gets cancelled down. You see this one and this one will get cancelled down. Gamma sat into Z minus gamma W into Z, which is going to be gamma dash into Z. And what else left over here? Plus 0 and the minus of this is going to be minus, right? minus of minus plus gamma W into H. So please look over this equation. What happened due to seepage? What happened? See, I did not use any conditions over here. I just applied. What is the difference from here to here? What is the difference that you are seeing, please? The difference is from here to here. If I open the tap and I keep a beaker, then there is a seepage. And due to seepage, what is going to be happen? Then the effective stress is going to be increases or decreases? The effective stress is going to be increases by how much times? The effective stress is going to be increases by gamma W into H. So I hope you understood how to solve this one. If you know this one, come on. Now, I'm going to explain as a logic. If you know this one, I'm going to explain the logic. The logic over here is, you see the logic here. First of all, you compare both. This is case 1 and this is case 2. You compare both. Is there any change in the total stress? Please look over here. Is there any change in the total stress? In case 1 and in case 2, the total stress is going to be same. In case 1 and in case 2, the total stress is going to be same. So now I can write by comparing So can we write this up? By comparing 1 and 2, by comparing case 1 and 2, case 1 and 2, you see the change in total stress is equals to 0. The change in total stress is equals to 0. Now you know that when the change in total stress is going to be 0, the change in effective stress is equals to minus of change in pore water pressure. Yes or no? Minus of change in pore water pressure means, see, can I write the change in effective stress is equals to minus of change in pore water pressure? You please have a look over here. Are baba, pehle ye pressure head means in the initial case 1, this is the pressure head HP. In the case 2, this is the pressure head HP, which means the pressure head has been fallen down by H. So you see minus gamma W into delta HP, which is equals to minus gamma W into minus H. Then you can write directly this value as is equals to gamma W into minus of minus, yes, minus gamma W into delta HP. So delta sigma dash is equals to minus gamma W into minus H, which is going to be gamma W into H. So I can say by comparing case 1 and case 2, you can see the effective stress increases directly by gamma W into H. So I hope you understood the meaning behind this. So if this is the case, then what about the upward seepage, sir? What about the upward seepage, sir? In the case of the upward seepage, sir, in the case of the upward seepage, what is going to be happening? Let's have a look. I hope you understood the condition over here, please. Yes. There is nothing you need to understand in this slide because we know all these cases earlier. Yes, this test is exactly similar to the constant head permeability test. You see, this figure is exactly similar to the constant head permeability test. In the case of constant head permeability test also, I have given the same setup by keeping constant supply of water and making sure this water level is constant, so that the difference between these two water levels is going to be constant as H. Now, upward seepage. This is case 3. Here, case 3, upward seepage. So same, upward seepage also I am going to take the same soil mass. I am not going to change anything. What I am going to change, you please observe the changes. There you can get down the answers. In the case of upward seepage, again, so in the case of upward seepage, again, you see, this is nothing but a soil. Same thing I am going to take, and so now this is going to be water, and here it is going to be water table, and you know the height of water is going to be HW and depth is going to be Z. Let's take it as Z. So this time I'm not going to draw again those figures. So once again, so now what I'm going to do here is, you know, beneath this there is a tap. Yes. Beneath this there is a tap. So this time what I do is, see, earlier I close the tap. Next I open the tap, I kept a beaker. Now what I do is, I connect this one to a high head water table. How, sir? You observe how I am going to do that. Now, you see what I am representing here is, see, I am connecting this pipe to a high head water table. I am connecting to this a high head water table. So now you observe this is a high head water level. So this is a one water level and this is a other water level. So now you tell me the flow will be takes place from 1 to 2, right? So see, earlier there was a tap over here. There was a tap. Now I connected this tap to a pipe. So when I connect a pipe, now you see the flow will be taking place 1 to 2, which means flow will comes over here through the pipe, and then this is the point of where the flow is going to be start. Is it a upward seepage or downward seepage now? Upward seepage. Already soil is going to be fully saturated because of the water table above present in it. Already the soil is fully saturated because of the water table present above in it. See, this condition is just exactly remembrance of the artesian condition. Yes. So where I kept the bore well at the bottom, it will rise to certain height. So now this unit weight is gamma W, and here unit weight is going to be gamma sat. Here unit weight is going to be gamma sat. Everybody, the same point again at A, where I took at the bottom, where I took at the bottom, where I took at the bottom. So now at A. Can you please find out what is the total stress, effective stress, and pore water pressure, please? At A. What is the total stress? Total stress is same. Wherever you want here, gamma W HW plus gamma sat into Z. No change in the total stress at all. No change in the total stress at all. So now, at this point, what is the pore water pressure? Gamma W into HP. Gamma W into HP. Yes or no? Gamma W into HP. When it is going to be gamma W into HP, now what is the pressure head? How to find out the pressure head? Insert the piezometer. So just insert the piezometer, please, here. If I insert the piezometer, over here, you tell me, see, this is the initial water level, right? Now, you go back once. See, here it is a downward seepage or upward seepage? Downward seepage. So now the flow is taking place from here. But now where I am taking the stresses? At point A. So as I want at point A, from here to here, the water has been traveled a distance of Z. So definitely there is a head loss. That is the reason why the water level in the piezometer falls from this point to this point. Yes or no? Now, you observe this condition, case 1 and case 3. See, initially in the case 1, the water level will rise up to the piezometer only, means water table, which means up to this point only. Yes, when initially. But now, due to this upward seepage, the seepage is going to be starts to move from here. Yes or no? At the starting point, what is the head loss? 0. What is the meaning of 0 head loss? This is a starting point. Starting point, head loss 0, which means the water level will rises to the corresponding water table. So now when the head loss is going to be 0, the water level rises, and not up to here. It is going to be rises up to this point, because this is the head that is going to be helpful to cause the flow or not. Now, as you move further, then the water level falls from here. This is initial water level, right? So then the water level falls somewhere over here. So by the time you reach over here, water level may fall somewhere over here. By the time you reach over here, water level falls to this level. So I have explained all these things. If you still have any doubt, you please go through the chapter number 6 quantum concepts are there. I explained you briefly, thoroughly with examples. So what is the pressure head now? The pressure head is going to be, what is the difference between these two? You know that the difference between these two is a hydraulic head. So what is the pressure head from the figure? From the figure, pressure head HP is equals to H plus HW plus Z. Then what is pore water pressure? Gamma W HW plus gamma W into Z plus gamma W into H. Then effective stress is equals to total stress minus pore water pressure. Then effective stress. What is effective stress, please? Finally, what is the effective stress we are going to attain? the effective stress is equals to, we are going to get that effective stress as, you see, gamma WHW, gamma WHW gone, gamma sat into Z minus gamma W into Z, gamma dash into Z minus U, right? Minus gamma W into H. Minus gamma W into H. So now you please look over all the three conditions once again. Whatever the difference I am making, you see, now comparing one and three, comparing 1 and 3, the change in total stress is equals to 0, and water level in piezometer rises by H, which means delta HP is equals to H. So then delta sigma dash is equals to minus delta U, which means minus gamma W into H. This is the logic I have made over here. You know this logics again and again I am representing you so that you would be understand the conditions clearly. Arey Baba, pehle case 1, sigma dash is equals to gamma dash into Z. Now, in the case of case 3, as water level in piezometer rises by H, you see, this is initial water level, right? That is the initial water level in the piezometer when there is no hydros, means when there is no flow. But due to flow, and in the case of upward seepage, water level rises by how much? H. Then pressure head rises by H. Then effective stress decreases by minus gamma W into H. So initially gamma dash into Z, finally gamma dash into Z minus gamma W into H. And in the case of the downward seepage, the pore water pressure decreases by H. So then effective stress will increase by gamma W into H. So this is what I want to say, and the conclusion is going to be due to seepage, whatever the effective stress is going to be changes. So downward seepage increases the effective stress, whereas upward seepage decreases the effective stress. I told you the effective stress is responsible for all the engineering behavior. Yes. Now you tell me which seepage is going to be uncontrollable. So from this, I can write down conclusions as no flow, effective stress is gamma dash into Z. Downward seepage, effective stress is equals to gamma dash into Z plus gamma W into H. And or I can write directly downward seepage. In this fashion I can write, right? Then effective stress is equals to gamma dash into Z plus gamma W into H. Then third one, upward seepage, effective stress is equals to gamma dash into Z minus gamma W into H. So we can write in such a way, this effective stress is equals to gamma dash into Z plus R minus gamma W into H. So now, sir, you said the seepage pressure, seepage pressure, seepage pressure. What is the seepage pressure, sir? Sir, what is the mean by artesian pressure, sir? What is mean by artesian pressure? Gamma W into HA. If the head is going to be HA, artesian pressure, gamma W into HA. Yes? What is meant by capillary pressure, sir? If the H is going to be HA, then the artesian pressure is going to be gamma W into HA. If the H is going to be HC, what is meant by HC? Capillary head. Then capillary pressure is going to be gamma W into HC. If the H is going to be pressure head, then pore water pressure is going to be gamma W into HB. Then if that is the case, if the head is going to be seepage head, if the head is going to be seepage head, then what is the seepage pressure? Artesian head HA, artesian pressure gamma W into HA. Seepage head H. Seepage pressure is going to be gamma W into H. So how you are going to find out this seepage head is a difference, total difference between water levels, which is nothing but the total hydraulic head. So now you see, as I am observing this one, where H is going to be seepage head, then this gamma W into H is going to be seepage pressure. Now this is the seepage pressure. So there comes the definition of the seepage pressure. So seepage pressure represent with PS. Seepage pressure represent with PS. You observe carefully. What is meant by seepage pressure? So seepage means flow, right? So what is the pore water pressure? The pressure exerted by water present in the pores. Now apart from that pore water pressure, when there is a seepage in the pores, then this seepage will exert some pressure or not. That pressure is known as a seepage pressure. So I can write this one as pressure exerted by water along the direction of flow. So this is the point. How to remember? So some of the people might ask me, sir, how come I remember all these things, sir? Now you see the definition of the seepage pressure, sir. Seepage pressure is the pressure exerted by water along the direction of flow with the magnitude. What is the magnitude? Seepage pressure gamma W into H. So what is the meaning of this direction of flow, sir? Now everybody have a look. Everywhere the weight of the soil acts downward. Yes or no? The weight of the soil acts always downward. So when the weight of the soil always acts downward, then the submerged pressure will act always downward. Yes. See, if the weight of the always the weight of the soil mass is going to be acts downward. Keep that in your mind. And minded here, the weight going to be here as a submerged weight or not. What is meant by gamma dash? Submerged unit weight. So it is going to be always acts downward. So always submerged pressure acts downward, which means that represents the weight. So now, as I told you, in the case of the downward seepage, obviously the weight of the soil, which means gamma dash, is going to be always downward. Gamma dash into Z is always downward. But now you tell me, in the case of the downward seepage, pressure exerted by water along the direction of flow. What is the direction of flow here? So the direction of flow is going to be, in the case of downward seepage, the direction of flow is going to be downward. So already the weight of the soil mass is going to be downward. Now the seepage is also going to be downward. So let's take these are the 2 pens. So now you see, if you observe, these are the 2 pens. Observe clearly. If I say this is going to be gamma dash into Z, it always acts downward, and this is gamma W into H. In the case of the downward seepage, both are going to be acting downward because weight downward, seepage also downward. Both are acting in the same direction. Now, can I write this seepage pressure acts also downward? Then what is the resultant effective stress? Plus. So now you see, In the case of downward seepage, what is the effective stress? Gamma dash into Z plus gamma W into H. I hope you understood now. Similarly, in upward seepage, can you please tell me what happens in upward seepage? In the case of the upward seepage, the downward is going to be gamma dash into Z. But as the seepage is going to be upward, the seepage pressure acts along the direction of flow. The seepage acts along the direction of flow, which means now here it is going to be minus. So I hope you know the signs between the water pressures over here. Always gamma dash into Z is going to be downward. Now the seepage pressure acts along the direction of flow. Upward flow, upward direction. Downward flow, downward direction. See, I explained you a lot of things over here. The concept, I explained you conceptually how to determine the stresses. And I explained you by means of the logic. See, by comparing 1 and 3, the delta sigma is going to be 0 and water level in piezometer rises. See, the water level in the piezometer, compare it to 1 and 3. This is 1, this is case 1 and this is going to be case 3. Compared to here, in this piezometer, the water level is going to be rises H times more. Then the pore water pressure rises H times more. Then effective stress decreases by gamma W into H. So I hope you understood this. Please have a look once. Please have a look once. Mr. Kaushik, the chapters are getting little complicated. There is no complication. You please go through all the 6th, 7th, 8th chapters. The concept I have mentioned is only two. One is finding the stresses, other is finding the pressure heads. See, when there is a flow, there is a head loss. Just apply the logic. That's it. There is no complication over here. If you want to remember, then there is a complication. But if you want to understand, there is no complication. Mr. Gaurav, sir, for upward seepage, why we have taken the pressure head at point A? Seepage is not started at point A. See, I am finding the stresses everywhere. See, I am checking. Look, why I have taken point A is everywhere I am saying the same point so that I can make you some conclusions. The conclusions are at the same points. If there is a downward seepage, what happens? If there is an upward seepage, what happens? If there is no flow, what happens? And at A, the seepage has not started yet, so there is no head loss. When there is no head loss, then the pressure would be there or not. Arey Baba, you are not moving, but you have some energy. What is that energy? Hydraulic head. When you move, you lost your energy. What is that? Head loss. I'll explain you one more cases also. Wait. I'll explain you one more case. First, you please go through this one. So one of our student is asked, sir, when there is no flow, you people are saying that when there is no flow, we can find out pore water pressure. If there is a flow, we have to find out seepage pressure. You see these three conditions. First, what I have done? Total stress. Then I have done pore water pressure. Then I have find out the effective stress. Here, total stress, pore water pressure, effective stress. Here, total stress, pore water pressure, effective stress. These are the basic concepts we know or not? Now I am telling you simply. But now you see, this total stress depends upon the pore water pressure and this effective stress depends upon the total stress and pore water pressure. You observe in all the three cases, total stress remains same. In all the three cases, total stress remains same. When total stress remains same, then the change in effective stress is due to change in pore water pressure or not? Okay. So now you see, you know how to find out the pressure head. You just find out the pressure head. What is this pressure head here? HP. Because when there is no flow, there is no loss of head. And in the case of the downward seepage, when there is a flow, there is a head loss. So water level falls from 1 to 2. Water level falls from 1 to, this is 2, 1 to 2 by H times. When water level falls by 2, then the pressure head will falls by H. When the pressure head will falls by H, you see here, I am explaining you. When the pressure head falls by H, then effective stress will increases by gamma W into H compared to the initial. So similarly, the same thing happens over here. In the case of the upward seepage, so when there is a piezometer, if you insert, the water level will rises to the corresponding water table. You know this, all these points are in starting chapters only. I don't mean, so with this, if you still don't understand, means you people did not gone through the chapter number 6 concepts. The people who have gone through the chapter number 6 concepts, I took a lot of time and I took a lot of efforts to make you should understand in 3 steps. Step 1, hydraulic gradient. Step 2, head loss. Step 3, how to determine the pressure head, and all those things I explained you clearly there. So some of the students are asking, sir, why you are taking it point A only? Baba, I just said that in order to make you understand the differences in the stresses, I am going to discuss you the special condition. So after a break, it's already 1 o'clock, 11 o'clock. So let's have a break. And after the break, I'll give you this condition. So please go through that once again. Please have a break. And it's now 11:02. Please come by 11:20. By 11:20, please come. Yeah, you don't need to worry. Means I'm not discussing anything. I'm just writing down the conditions so that when everyone comes, so they will be able to see that I will start the session then. So it means I'm just drawing the sections. I'm just drawing the things. I'm just drawing the things. So don't worry, I'm not starting a class. I'll be starting the class after 11:20 only. But before that, I'm just drawing the things. So that we can save this time. Yes. So I hope people have been started. So how can private college students compete with IITians in GATE, sir? So there is no Other options are you have to do hard work. That's it. That's the only option that you have. Work hard, work hard, work hard, and to make sure yourself in a smarter. See, at first your work should be in the hardest way to make your work later as a smartest way. So the only way that you can compete with IITians, see, IITians is also just a student like you. I am not a born IITian. I have done my BTech in a normal university only, which is SV University. And I went into IIT MTech in IIT Hyderabad. So you don't need to be an IITian or you don't need to be some other person. The first thing is you require your will. If you have willpower, then you can solve it. So you don't need to make sure yourself like at this level, IITians are this level or some other private students are this level. So your levels are everything same, but your perception is not going to be the same. The way that you are going to think about yourself, that all matters. See, please think yourself that you can do it. So when you can do it, if you can work hard, then you can do it, obviously. The IITian, if he is an IITian, and if he still sits idle in his room, do you think he is going to get a rank? No. Though he is an IITian because he entered into IIT. So he is just a human being like you. So you don't need to worry about that. You work hard, then you will definitely get a rank. Sir, I mailed you question number 5 of chapter number 5. The answer was 47. Please respond. Mr. Kaushik, I'll respond to the mail. I have not seen that mail. I'll see the mail after the class and I'll respond to you, Mr. Kaushik Budige. Is shrinkage index same as a shrinkage ratio? Please go through the notes that I have given. If you see the notes, then you will be getting to the difference, shrinkage index and shrinkage ratio. Mr. Rahul Sharma, I have started my preparation only 2 months back. Will I be able to get good rank in GATE and ESE? Mr. Rahul, I think I have given you the, means you have sent me the mail. So I have sent you the details to that mail also. You don't need to worry. I hope everybody reached out. So now let's see what I want to discuss over here is still a lot of people I have to come, but let them. So it's already 11:25. So please explain CRPQ 5th question in permeability chapter. That's the only one question that I have given you. So today, after this, at the end, I'll take 15 minutes. Once the class completes, I'll take 15 minutes of time. So I'll give you the GATE preparation strategy, how to prepare, because we have started the subject, right? So we are about to complete the chapter number 8 also. So I'll give you the preparation strategy at the end of the session, not in between. So I'll share with the preparation strategy, what I have been through and how I have got the GATE rank in means in GATE 2012 and 13, how I got GATE rank and how I have prepared. So I'll share that strategy at the end of the session. So now you see, some of the people were asking, sir, why you have taken point A, point A, point A. Now I'll be taking some section in between. Let's take the section in between. Now I will show you the difference between these two conditions are here. You please observe this carefully. I'll explain it basically, then at the end I'm going to conclude with a logic. So everybody out there, you please tell me what is the total stress at this condition. What is the total stress at this condition? So at XX, everyone, now I'm looking over this condition at XX. I hope everybody will get these values at XX. What is the total stress, please? The total stress is, this is nothing but water. What is the unit weight of water? Gamma W. So I don't say every time gamma W, gamma sand. I told you this is going to be a soil which is filled with the water, which is gamma sand, and here it is going to be gamma W. So gamma W HW plus gamma sat into ZX. You see, this HW is the height of water. and Z is the total depth of the soil mass. Let me take a section XX at a depth of ZX below the water table. So at a depth of ZX below the water table. Now, is it a downward seepage or upward seepage? Downward seepage. So what about the pore water pressure? The pore water pressure is gamma W into HB. Okay, fine. Gamma W into HB. So I need to find out the HB. So you can write down the total stress. Now the question is entirely depends upon this HB. How to find out the pressure head? So I am making the concept simpler. How to find out the pressure head? Pressure head can be found out by inserting the piezometer. So now let's insert the piezometer. Let's insert a piezometer. If I insert a piezometer, yes. If I insert your piezometer, see, I inserted a piezometer over here. Now everybody, you please tell me, does the water level rises to the rear water table? This is level 1 and this is a level 2. So now you tell me, is it a downward seepage or upward seepage? This is a downward seepage. Clearly, it is mentioning that it is going to be a downward seepage. Flow takes place from 1 to 2. Higher water level to lower water level. This is a downward seepage. I hope you understood the meaning over here. Now, by the time you reach over here, you travel how much distance from here to here? You travel a distance of ZX. You travel a distance of ZX. By the time you reach the distance of ZX, you please look over. You are here. You are here. You travel a distance of ZX. Then definitely you lose head. When there is a loss of head, then there is a fall of water level. So water level will fall. Water level will fall by a head, where is known as HX. And whatever the remaining, this is known as pressure head, HP of X. So where HX is head loss up to X, and length traveled and seepage length up to XX is ZX. Seepage length up to XX is going to be ZX. So now we need to find out this HX. We need to find out the HX. How to find out the HX? You know that I is equals to H by Z, which is equals to HX by ZX. So HX is equals to I into ZX. This is a step number 1. If you remember the steps, I hope you remember these steps, I value and HX value. Once you know this one, then what is HP of X? You please tell me. Then HP of X is equals to, then HX is equals to I into ZX. Okay. So then HP of X from figure, HP at X is equals to, what is the pressure head at X? You please tell me. I want this value. How from figure, you please tell me what is this value? This value is going to be HW plus ZX. HW plus ZX minus HX. You see, I want this value. Everybody, I want this value from this figure. You observe, this is nothing but the HW plus ZX minus HX will give the HP of X. Okay, I hope you understood the meaning behind this. So now you substitute over here, then what is our pore water pressure? Gamma W HW plus gamma W into ZX minus gamma W into HX. Then effective stress is equals to gamma W HW, gamma W HW gone. Gamma sat into ZX, gamma W into ZX, gamma dash into ZX plus gamma W into HX. See, sir, why you are discussing again this one? I'll tell you later. I hope you understood this. So now this is a effective stress. Let's see what about the condition. Let's see what about the condition in the case of the upward seepage. I hope everybody understood over here. So now I'm going for the upward seepage condition. So upward seepage condition. See, if you can understand these logics, then you can solve at any point. Again, come over here. This is XX. Let's take the ZX as a depth below the ground surface, means this water level. So what is yet XX? Come on, please. Again, you please tell me what is the total stress, please. Total stress means gamma W into HW plus gamma sat into ZX. Gamma W into HW plus gamma sat into ZX. That is the total stress because I am taking this as ZX. But what about pore water pressure? Gamma W into HP. What about pore water pressure? Gamma W into HP of X. So how to find out the pressure head at X? Now everybody have a look again. Now this time, is it upward seepage or downward seepage? This is a upward seepage. This is a upward seepage. So now, can you please tell me what is the length up to X? See, you observe the total is going to be Z and this is going to be ZX. Then what is the length up to X? LX, where LX is length of or seepage length up to X. See, sir, the basic difference over here, here I took ZX as a seepage length, here I took ZX as a seepage length, but whereas here the ZX is not going to be seepage length because here the seepage is upward seepage or downward seepage. This is an upward seepage. So as it is an upward seepage, LX is a length of a seepage up to X. So what is this LX value, please, here? Everybody, the LX is going to be Z minus ZX. Then what about the HX, sir? HX is equals to I into length up to X, sir. So I into, you please keep it aside. So means you know that HX is equals to I into length up to X. Okay, fine. So now I insert a piezometer. I insert a piezometer. So now you tell me, you see, this is initial water level. Yes or no? You observe. Now let me complete these things with the earlier one. You observe here. Array, this is the starting point now, upward seepage ka. A starting point में कोई head loss है? नहीं. When there is no head loss, water level will rises to the top. But now, as you travel a distance of Lx, definitely there is a head loss, which is X, which is going to be X. So now you see the water level will rises into the piezometer, and this water level will not rises to the upstream water level. This is 1, this is 2, and the flow is going to be upward seepage, but water level will falls by Hx. Water level will fall by Hx. So what is this Hx, sir? Now you please look over here. Whatever the total seepage head, this is nothing but the total seepage head R0. Whatever the total seepage head or hydraulic head is going to be this is H, and this is going to be HP of X. So can you please tell me from piezometer, what is HP of X we got? You come on, you please look over here, everybody. See what is this total point from here to here? What is the total height, please? H plus HW plus ZX. So I can write H plus HW plus ZX minus HX. So with this I can write, then pore water pressure is going to be gamma W into HW plus gamma W into ZX plus gamma W into H minus HX. Now you see this relation between these two. You observe between these two. If you observe these two, you see the pore water pressure here. You see the pore water pressure over here. You see the total stress over here. You see the total stress over here. So I have not done anything. I just applied the things. Now gamma W HW, gamma W HW, gamma dash, gamma W into ZX, gamma W into ZX. Now gamma W, this is HX, and this is H minus HX. What is this? H minus HX. So what is H, sir? What is H? Please tell me. What is normally H means? So this H is H total hydraulic head, total hydraulic head, and Hs of X is going to be hydraulic head yet XX. So I can write this head. See, now you please listen to the point. What I am saying is very, very important point. When you start, what is your energy you have? H. That is the total hydraulic head you have. But by the time you reach over here, what is the seepage head you have? Hs of X. What is the seepage head you have? Hs of X. So in the case of the Hs of X, what is the seepage Hs of X? Seepage head or hydraulic head X. Papa, you have H. When you travel over a length Lx, you lost some head, right? Which is nothing but Hx. And what is the seepage head you have? H minus Hx. So I can write this one as gamma W into H minus Hx, then Hs of X is equals to H minus Hx. What is this Hs of X? Seepage head yet X. So now if you apply all these things, see, first let me write down. Then what is effective stress? Effective stress means total stress minus pore water pressure. So then effective stress is equals to total stress, gamma WHW, gamma WHW gone, gamma sat into Z minus gamma W into H, gamma dash into Z minus gamma W into H minus Hx. Then effective stress is equals to gamma W into Zx minus gamma W into Hs of X, where Hs of X is going to be seepage head at X. You observe these two conditions, please. Everybody, you please observe these two conditions once again. So I want you to understand the relation between these two. So what I am going to do here is, in the case of the downward seepage, and upward seepage, see this portion is constant, gamma dash into Zx, because I am taking a downward, the depth of below. But in the case of the downward seepage, this is going to be gamma W into Hx now, gamma W into Hx. So what is meant by gamma W into Hx? This Hx is going to be head loss up to that point, because the seepage is downward, right? Head loss up to that point. Whereas in the case of the upward seepage, you are going to take what is the seepage head at this point. This is the seepage head at this point, Hs of x. So if you can know these points, please give me a minute. You please go through. So now I hope you understood the point over here. So I am going to discuss about the logic. The logic is just simply, you see, what is the total head at the point over here? Yeah, I mean, I'll write over the point. See, when you travel, I mean, I'm just taking an example. Please observe this point over here. When you travel, let's take the total length as a L. Now you are here. When you travel, initially you have a total head as a H. This is a hydraulic head. You have total hydraulic head as H. Now, when you travel a distance of Lx, by the time you travel the distance of Lx, you see your energy would be less or not? Your energy would be less. Where your energy is going to be less, do you think the head is going to be same over here? No. That is known as Hs of x. So what is Hs of x? Hs of x means seepage or hydraulic head at section x. So how to find out this seepage head, sir? Sir, you know that total seepage head, which is going to be H, which is a total seepage or hydraulic head. Total seepage or hydraulic head. So now, if you observe, what is the seepage head at x is equals to, what is the one you have traveled with? H. And by the time you travel a distance over a length of Lx. When you travel a length of Lx, definitely you lost some head or not? Yes. Arey, mera energy pehle, just take my energy is going to be 5 meters. Now let's say I lost of 2 meters of head. Then what is the seepage head over here? 5 minus 2, which is going to be 3 meters. Which means I can say whatever the total seepage head, I can say whatever the total seepage head at starting minus head I lost at the x, which is nothing but H minus Hx, where Hx is head loss up to x. Hx is head loss up to x. So I hope you understood the meaning over here. So that is the reason why, see, once I went mathematically, then I am writing what is this H minus Hx? The H minus Hx is going to be Hs of x, which is nothing but seepage head at x. So now finally the logic is going to be, the logic is for downward seepage, if this is a section xx, you know always the downward pressure is going to be acts down. Means the submerged pressure always acts downward. Yes or no? Submerged pressure always acts downward. So this is gamma dash into Zx. And what about the seepage? Seepage also always acts downward or not? When the seepage also always acts downward, then this is going to be gamma W into Hx. So In the case of the downward seepage, at any section you take, effective stress is gamma dash into Zx plus gamma W into Hx. Whereas this Hx is going to be head loss up to X. Whereas Hx is going to be head loss up to X. Now, in the case of the upward seepage, now in the case of the upward seepage, you see, again this is a section XX, but always, you know that always the unit weight of the soil mass means submerged unit weight always acts downward, which means this is gamma dash into Zx. Whereas upward seepage is acting downward, right? So now this is going to be gamma W into Hs of X. So then what is effective stress over here at any section X is equals to gamma dash into Zx minus gamma W into Hs of X, where Hs of X is going to be balanced or remaining seepage head at X. So we can write the same thing over here. So this is nothing but balanced or remaining seepage or hydraulic head at XX. So I hope you understood this. See, finally I made this logic so that you people can go through this one. There is a logic. You see, I have explained you in the basic. You please go through this. I have explained you in the basic. I provided you the piezometers and I explained you the basic concept. And I made at the end, I got these conclusions. See, this is the final answer at any XX and this is the final answer at any XS. So from this, I have written this point. Please go through this one once again. Mr. Ketan Dalvi, is HP of X and HS of X is not same? Is same? No. If it is same, then I would have said you right. The HP of X is nothing but pressure head, Nana. The HP of X is going to be pressure head at X, whereas Hx is a seepage head. Seepage is a difference. Pressure head is going to be different. Again, why you people are asking the same thing, Ray? This pressure head, this is a pressure head, Nana. HP of X is a pressure head, please. What is the pressure head over here? You see, you observe, means a figure, from the figure perspective, I'll explain you. From the figure perspective, I'll explain you. Please, everybody have a look. This is nothing but H minus Hx, yes? And this is going to be the net head. What is the total seepage head I have started with? The total seepage head I started with H. Now, as I travel, I lost Hx. When I lost Hx, then this remaining is going to be seepage head at X. Then this remaining is going to be seepage head at X. You know, this H is nothing but total hydraulic head and Hs of X a hydraulic head at XX. So, as the water level falls by Hx, the remaining Hs of X is going to be H minus Hx. Now, Mr. Kaushik, sir, can we say seepage head as a head left over after head loss? Yes. It is a head loss, that head left over. Okay. Now, let's see one of the previous gate questions. So I took this much of time so that you people can understand the logics and basics. So let me take you that now. You please listen first this question. Yes. This is chapter number 7. This is chapter number 8. You please look over this question, everybody. Yes. See, this is a previous GATE question. This was asked in a GATE 2016. So now I want you to look over this condition. A seepage flow condition is given over here. So first of all, you only tell me, does it downward seepage or upward seepage? This is level 1. This is level 2. Flow occurs from 1 to 2. So here flow is it a downward seepage or upward seepage? This is a downward seepage. This is a downward seepage. So flow is taking place from 1 to 2. Then the flow happens in a downward. So they have given the details. The details were like, see, they have provided the water tables. They give the difference between the water tables. What is the difference between the water tables? The total seepage head H is equals to 3 meters. And they have given the difference between these levels as 1 meter. And total distance, the total depth of the soil mass. What is the total depth of the soil mass here? This is 6 meters because this is the total depth of the soil mass. And now what they're asking is, using unit weight water, the effective stress at XX. This is the effective stress at XX. So let's take this is a GATE 2016, I think so, 2015 or 16. So now let's see this question. So previous GATE question. So first let me draw that. So this is a soil element I have given you, and observe this is a water table, and here also there is a water table, and there is a yet XX. So the details were given as so the details were given as observe the difference between the water levels as 3 meters. The difference between the here is going to be 1 meter. And this is 5 meters, and here it is given as 1 meter. So you know the total depth of the soil. Now you tell me, what is the total depth of the soil? The total depth of the soil, Z is equals to 6 meters. Now, what is the H value difference between water levels as 3 meters? So first, I'll go with a basic. the basic way, I want the effective stress at XX, which means total stress minus pore water pressure. So first of all, can you please tell me, see what is the unit weight of the soil they have mentioned? 18 kilonewton per meter cube. Now, so whatever the gamma W is going to be 9.81. So this is a question as a numerical type, and they did not mention as a rounded to 2 decimals. So they will give the range of the values. So now the effective stress at XX. So gamma W, unit weight of the gamma W as 9.81 kilonewton per meter cube. Most of the people, what they do wrong is they will take this value, but what about this value? What about this value? This is also going to be water or not? Yes or no? So now, what is the total weight of, means height of water on the soil? What is the total height of water? Do you think this is the only height of water? No. The total height of water is going to be simply the total. Whatever this total height, what is this total height now? You tell me. 3 plus 1, that is the total height of water. See, this is gamma W, and inside this is also going to be gamma W. That is also fetches some weight or not, plus gamma sat into ZX. So this 5 meters is going to be ZX. Why? The seepage is going to be a downward seepage from 1 to 2. The flow will be takes place. So now 9.81 into what is the HW? 3 plus 1 plus gamma sat 18 into 5. So you please tell me the total stress. What is it? Yes. The total stress is going to be 9.81 into 4 plus 18 into 5, which is going to be 129.24 kilopascals. And now we need to find out the pore water pressure. What is pore water pressure? Gamma W into HP of X. How to find out HP of X? Step number 1. So what is I value? I value means H by Z over here. What is H? 3 by 6, which is going to be 0.5. You know that the physical meaning of hydraulic gradient means head loss per unit length. So head loss per unit length means what is 0.5? Array 1 meter travel, you lost 0.5. But how much distance you are going to travel here? 5 meters, right? You are going to travel exactly the 5 meters. So when you travel a 5 meters of length, then Hx is equals to I into Zx 0.5 into 5, which is going to be 2.5 meters. Which means when you insert a piezometer, when you insert the piezometer, by the time water level reaches to this point, by the time water level reaches to XX, means by the time it travels 5 meters, then the water level in the piezometer will fall. See, this is initial water level or not? The water level in the piezometer will fall by 2.5 meters. This is a H value, and whatever this is nothing but the Hx. What is this? Hx. So, and remaining is going to be HP of X. Now you tell me what is HP of X, please. So what is the HP of X, please? HP of X is equals to, HP of X is equals to, from this point to this point, what is the total? 3 plus 1 plus 5 minus Hx. 3 plus 1 plus 5, which is going to be 3 plus 4, 5, sorry, 4 plus 9, 9 minus 2.5, 9 minus 2.5. So 3 plus 1 is 4, 4 plus 5, 5, 5, 9 minus 2.5, which is going to be 6.5. Then what about pore water pressure? 9.81 into 6.5. which is going to be 63.765 kilopascals. Then what is the effective stress at XX? 129.24 minus 63.75, which is going to be 65.47 kilopascals. So they will give you the range as 65 to 66 kilopascals. The answer would be 65 to 66 kilopascals, Nana. So that's the answer. So you please look over here first of all. I have done this one earlier. Earlier also I have done this one. So you know this is nothing but step 1, and you know this is nothing but step 2, and this is nothing but step 3. You please go through all those things. So I value, HX value, then pressure head. So once we know the pressure head, then you can find out the pore water pressure. Now, you see, now I'm going to apply the logic. When I apply the logic is very simple. The logic is whatever it is, whether it is a downward or upward, you know that for the submerged, see, whatever the weight of water above does not change anything in the effective stress. So the logic is downward is gamma dash into Zx, and there is a C phase, downward C phase, gamma W into Hx. So you see, this is the logic I have given you, right? Downward C phase, gamma dash into Zx plus gamma W into Hx. So first of all, then effective stress is equals to gamma dash into Zx plus gamma W into Hx. You need to find out the Hx. What is Hx? I into length up to x. Whatever the length up to x is nothing but z up to x. So what is z up to x over here? Here I'll write Lx only, where Lx and Zx both are same. So what is this value? 5. And you know I value, what is I value? H by L, 3 by 6 into 5, which is going to be 2.5 meters. So this is the only step you are going to find out here. Then what is effective stress? Gamma dash, which is nothing but 18 minus 9.81 into Zx 5 plus 9.81 into Hx as 2.5. Can you please tell me the effective stress? This is section XX. X, please tell me this value. 18 minus 9.81 into 5 plus 9.81 into 2.5. So same 65.475, then approximately 65 to 66 kilopascals. They will give you the range. This is the range. As it is a numerical type, they will give you the range. So now, people, I'm asking you, you can go through any procedure and you can get the same answer. But my preference for the examination is going to be this one. Simply, I know, yes, always submerged pressure acts downward. And as it is downward C phase, the C phase also acts downward. So gamma W into Hx, gamma dash into Zx, where Hx is head loss up to that point. Sir, does this logic ever fails? No. Any condition you take, it will apply. But you have to apply whatever the logic I said. So don't apply whatever the logic you understood. See, you go through this one. Mr. Limbasia, sir, by mathematically I understand, and I also understand the point practically that downward C phase exerts pressure. That's why increase in effective stress. but practically due to what effect head loss exert pressure in case of downward seepace, and due to what reason remaining head exerts pressure in upward seepace. I told you, see, in the case of the downward seepace means, you please observe, in the case of the downward seepace means already up to XX you have done work. Already Mr. Limbasia, you please listen, up to XX, you have already done work. See, for example, I am asking you, by the time you movement ZX, the head loss, what is the head loss? The meaning over here, 2.5. What is the meaning of this 2.5? Literally, you tell me. What is the physical meaning of 2.5? In order to travel from here to here over a distance of 5 meters, you require head of 2.5 meters. You require a head of 2.5 meters, which means you have done a work of head equivalent to 2.5 meters. Then here, what is the total seepace pressure you exerted is gamma W into 2.5. Yes or no? So by the time you reach this XX, you have done work of 2.5, which means you lost 2.5. But in the case of this one, you are going to do the work remaining. See, you want to go for a further. This is upward seepace. You are going further. When you go further, with what head you are going to go further? With the what head you are going to go further? HS of X. Seepace head at X. See, if you don't want to go for the logics, then you please go for the basic only. So I am not stressing you. If you want to go for the logic, you can go. But if you want to go for the basic, you can see these are the steps that are there. So I cannot, it's n number of times I explained the same thing continuously. So it will be again, if I explain more and more, then it will be more confusion also. So please go through that once. What is the difference between seepace head and seepace length? After all discussing this entire seepace, this is the question you are asking. What is the difference between seepace head and seepace length? It's like it's seriously, it's I will say whatever required only, because I explained with the examples and I told you what is meant by seepace length. You are there. You are there. The person who has asked this question, he asked in an anonymous attendee. So Mr. Anonymous attendee who has asked this one, you are there. Let's say your energy is going to be 100 calories. Minimum energy is going to be 100. Or let's say you want to travel 1 kilometer. Let's say you want to travel 1 kilometer. And for traveling 1 kilometer, you require some energy. And that energy is going to be some, let's say 100 calories. And whatever the length you travel now, 1 kilometer, that 1 kilometer is a seepace length. And for that 1 kilometer, whatever the energy you required is nothing but 100 calories, right? That 100 calories is seepace head. So seepace head is 100 calories at starting. And seepace length means 1 kilometer. Now, as you start to travel, when you travel, you lost your head. You lost your energy. So when you lost your energy, you see, when you lost your energy by the travel, I lost some 30 calories of energy. What is your head loss? 30 calories. And how much seepace head you have left over? The seepace head left over is going to be with what seepace head you started 100 minus how much you lost 30. So the leftover seepace is going to be 70 calories. So now the next moment you are going to travel, you travel with the 70 calories of energy or not. So now if you travel further and further, you lose energy further and further. Okay. One of the students, sir, why should you consider head loss in a downstream, that means downward seepage, and energy hit in upward seepage? Why don't consider the board heads? So my dear student, you please go through this explanation. I have made this explanation entirely. So the person who has asked, you please go through this explanation. And if in this explanation, if you see these 2 points, you can observe the change in the pore water pressure over here. The change in the pore water pressure. See here the gamma W into Hx, but here gamma W into H minus Hx. So you please go through that. That is the reason why I did not write it directly. I did not I did not write it directly. So now I'll take one more question. I'll take one more question. There's an example. Now I'll give you the question based upon the upward seepage. Same type of question, but I'll change the water levels. Observe. Same type of question, I'll change the water levels. So now you see the same question, but I am changing into in different fashion so that I want you to understand further. I want you to people. It's just for the sake of you only. So now you observe here, this is the difference between the water levels. This is one water table and this is one water table. The difference between the water levels are total head I have given as 3 meters. Now total length I am giving as 6 meters. And let's say this is going to be some 2 meters. And I want to find out the effective stress at a section XX. I want to find out the effective stress at section XX. So this XX is at a depth of 2 meters and this distance is going to be 4 meters. So now everybody, again, I hope you understood what is this. So you see here, this is a flow 1, 2, 2, which means the flow is going to be moves from here. Yes or no? Yes. So after all doing this, I hope you people are able to say, when do you say the upward seepage? When do you say the downward seepage? If you don't say now, then there is no meaning of I explained these many things to you. So flow is upward. Flow is upward. Let me go with the basic first. At XX, what is effective stress? Total stress minus pore water pressure. So let's give the gamma sat as a 19 kilonewton per meter cube and assume gamma W as a 10 kilonewton per meter cube. See, this is different example and this is different example. So I'm just changing these values. So now you tell me at this XX, come on everybody, at this XX, what is the total stress? What is the total stress? Now are you going to take this one also? No, this is the water, this is the water, this is the water. So now I can write gamma W into how many meters of water over there here? 2 meters. Plus gamma sat into how many meters of soil is there? 2 meters. This is soil, no? 2. So sigma x is equals to 10 into 2 plus 19 into 2. So 10 into 2, how much? 20 plus 19 into 2 plus 20, which is going to be 58 kilopascals. Then what about pore water pressure? Gamma W into HP of X. So how to find out the HP of X? So whenever you want to find out the pressure head, so now I told you, please insert the piezometer. Please insert the piezometer here. So I'll insert the piezometer. When I insert the piezometer, yes. So when you insert the piezometer, actually, initially this is the level of water. Yes. But now this is upward seepage. When there is an upward seepage, the length that is going to be traveled by the upward seepage from starting point to ending point. Here, the Lx is going to be, what is the distance traveled by the water from the starting point to the XX? Lx. So seepage length up to x. How many meters you are going to see here? Lx as a 4 meters. So now you know that h is equals to 3 meters, L is equals to 6 meters, I is equals to 3 by 6, which is going to be 0.5. Then hx is equals to I into length up to x, 0.5 into 4. Physical meaning of this I is head loss per unit length. So you lost 1 meter, means you lost 0.5 for every 1 meter. So you are traveling how many meters over here? 4 meters. When you travel 4 meters over here, then you tell me what is the head loss you are going to get? 2 meters. So then the water level will fall by 2 meters. So hx is equals to 2 meters. Then whatever the water level you are going to see, this is nothing but pressure head at x. So please tell me what is the pressure head at x? Pressure head at x is equals to from figure, what is the pressure head, Nana, please? 3 plus 2 plus 2. 3 plus 2 plus 2 minus 2, which is going to be 5 meters. Then what about the pore water pressure? Yes. Then what about the pore water pressure? Gamma W into HP of X, which is going to be 50, sorry, yes, 5 into 10, which is going to be 50 kilopascals. Then effective stress at X is equals to 58 minus 50, which is going to be 8 kilopascals. 8 kilopascals. So now you see the logic. Now you see the logic. Get this action XX. The logic is, first of all, in the case of the submerged unit weight, the submerged unit weight does not depends upon the above water. So whatever, this is nothing but gamma dash into ZX. Gamma dash into ZX. And now this one, already you have traveled from here to here, right? You lost some head. So whatever the head you have is nothing but gamma W into Hs of X. So what is Hs of X? Seephase head at X. So Hs of X means total seephase head minus head loss up to X. H minus Hx. So how to find out Hx? Hx is equals to I into length up to X. So Hx is equals to total I H 3 by 6. And what is the length up to X over here? 4. So which is going to be 2.5 meters. So not 2.5 meters, it is 2 meters, right? This is going to be 2 meters. Now, whatever the value you have, so what is the total head you have? You see, pictorially, you see, this is nothing but the seephase head at X. Yes or no? Pictorially. So what is the seephase head of X? Total 3 seephase head minus Hx as a 2. So 3 minus 2, which is going to be 1 meter. Then what is the effective stress? Effective stress is gamma dash into Zx minus gamma W into Hs of X. So what is this Zx over here? The Zx is 2 meters and this is going to be Lx. So now you tell me, what is this Zx? Gamma dash, come on please. 19 minus 10 into 2 minus 10 into 1. What is this value? 19 minus 10 into 2, 18. 19 minus 10, 9 into 2, 18. 18 minus 10, answer is going to be 8 kilopascals. So it's up to you, Nana. I'm leaving this. So I have given a n number of examples and a n number of solutions. So total stress from the level of water. Arey Baba, total stress is how come it's the level of water? You see, Re Baba, this is the 2 meters of level of water, right? Yes, what is this level? What is this water? 2 meters, na? This is 2 meters, gamma W into 2 plus gamma sat into 2. This is gamma sat, and here it is going to be gamma W. What is the total height of here? 2 plus gamma sat into 2. The answer is going to be 8 kilopascals. So you told Lx and Zx are same. Where I said Lx and Zx are same? Did I said Lx and Zx are same? See, what is the meaning over here? Lx and Zx. What is the meaning over here? The Lx means length up to the seephase. It is a downward seephase, yeah. When it is going to be downward seephase, see, this is a downward seephase, right? Keep your minds over here. Are you mad or what? Keep your minds over here. The person who is asking a question, this is a downward seephase and that is the upward seephase. I'm explaining you, you are here. When you are here, see, I am taking the Zx as a downward depth normally. Zx is downward depth normally. And when I say it is a downward seephase, in that downward direction, the depth and the seephase length both are same. Now, this is Zx over here. And I am saying, what is Lx over here? Seephase length up to length x. This is a downward seephase. This is upward seephase. So the seepage length is not going to be same every time. Seepage length depends upon the type of seepage. This is an upward seepage. You please go through the terms. You please go through the terms once again. I have given you here, this is ZX. Here also this is going to be ZX. But what is LX over here? You please look over here. What is LX over here? LX means length up to the seepage. Okay, so with this I am ending this. So the topic I have taken a lot of time, and still you people are asking the silly questions. So now, then what is the purpose of this all the discussions, sir? Seepage force per unit volume. Seepage force per unit volume. Per unit volume. So far I have discussed about the seepage pressure. Now I am going to discuss about the seepage force. So seepage force, you see seepage pressure. What is seepage pressure, please? You go back over here. What is seepage pressure? The seepage pressure is pressure exerted by water along the direction of flow. PS is equals to gamma W into H. Let's take an element. Again, for example, you take any flow, you take any seepage, whether it is a downward seepage, whether it is an upward seepage, whether it is a horizontal seepage, anything you take, I don't care, whether it is a downward or upward or horizontal seepage, you please look over here. So let me go with yes. So let me go with the downward seepage. So you can take anything, Nana. So let's take the soil mass will travel a total length of Z. See, do not fix your mind. Do not try to remember. Try to understand. What I am saying you is seepage length. So if the seepage is horizontal, then the seepage length is X. If the seepage length is vertical, then the seepage length is Y. Now, let's take the cross-section area. Let's take the cross-section area as E. So now, what is the seepage force, sir? Seepage force, Fs. Force is nothing but pressure into area. You know that force is nothing but pressure into area. So seepage force Fs is equals to pressure gamma W into H into E. Now, as it is a downward seepage, when the flow travels, there is a head loss. When the flow travels, there is a head loss. Then whatever the head loss from here to here is nothing but total head as a H. So you have traveled with a seepage at starting point as H, and this is going to be the 0. Now what is I value? Head loss per unit length. What is the length over here? Total length as Z. Total length as Z. See, I am not using, I can use ZRL because I am discussing what is that? Length. That seepage length. When it is downward, you have to take from top to bottom. When it is upward, you have to take from bottom to top. So now, can I write here as I H is equals to I into Z. Then what is seepage force? Gamma W into I into Z into A. You observe over here, this is a soil element or not? The total volume of soil element V. What is the volume of soil element over here? A into Z. So now I can write this seepage force Fs is equals to gamma W into I into volume. So then what is seepage force per unit volume? Gamma W into I, where I is going to be hydraulic gradient. So how to determine the seepage force per unit volume is gamma W into I. Similarly, submerged weight per unit volume. What is meant by submerged weight per unit volume? The submerged weight means W dash submerged weight per unit volume is nothing but the submerged unit weight or not. So I hope you remembered the saturated unit weight per unit volume, gamma sat, dry weight per unit volume, gamma D, and submerged weight per unit volume, gamma dash. So now I have given you the saturated weight and submerged weight. So now if it is a downward seepage, I am asking you resultant the forces. I am asking you, you see, if it is a downward seepage, what is the resultant force? You see, the weight is going to be act downward. Gamma dash, submerged weight per unit volume. And seepage force per unit volume is going to be gamma W into I. Then what is the resultant force per unit volume? The resultant force per unit volume, R by V is equals to, what is that resultant force per unit volume? Gamma dash plus gamma W into I. Similarly, if you go for the upward, then gamma dash minus gamma W into I. For example, let's take a horizontal seepage. In the case of horizontal seepage, see, you tell me, if it is a horizontal seepage, if I take an element like this, see, this is a horizontal seepage. So now I am showing you this is a horizontal seepage. Now you see length is L. Now we are going to travel in the horizontal distance, right? See, here I traveled vertical distance, so I write I equals to H by Z. Now it is going to be I equals to H by L. Understood or not? So here the seepage length is L and here the seepage length is going to be Z. I'm saying not depth or length. I'm saying the seepage length. The length traveled by water along the direction of flow. This is a horizontal. Now you know always the weight acts downward. Then the submerged weight per unit volume is equals to gamma dash. But whatever the seepage force, the seepage force along the direction, see always seepage pressure and seepage force both act along the direction of flow. Both acts along the direction of flow. So now what is the seepage force per unit volume over here? Gamma W into I. Sir, why you have taken the seepage per unit volume as a horizontal, sir? Because the seepage is horizontal, sir. But here, sir, seepage is downward, sir. So now what is the resultant force per unit volume, sir? The resultant force per unit volume. the resultant force per unit volume is equals to, now it's a square root of gamma W into I square plus gamma dash whole square. Gamma W into I square, it's a square root of, you know that, right? When there are going to be forces in two different directions, then the resultant is going to be square root of A square plus B square. I hope you understood this. Sir, can C-base be inclined? Yes, it can be inclined also. You can find out the inclination. I explained that topic of this permeability with the inclination only. So, now, so this is the C-base force per unit volume. So there was one question in the previous gate question. They have asked about this resultant force per unit volume. That's the reason why I discussed this topic. So now, what is the importance of this so far? See, in this entire chapters of 6 chapters, means 6th chapter, 7th chapter, and 8th chapter, I have been discussed so far. The conditions are: 6th one, permeability. In the case of the permeability, we discussed a C-base. 7th one, we discussed stresses. 8th one, combination of the stresses and a C-base. Now, what is the purpose of all these things? Why we need to study this C-base? Why? As an engineer, what is the importance of this C-base? Why we have to go for downward or upward or horizontal? Now, everything is going to be clear for you. Have a look, please. So this is a gravity dam. This is upstream bed and this is downstream bed. This is upstream water level and this is downstream water level. And now, this is an impervious stratum. Let's say this is a rock, which means the flow will not happen below this. So this is upstream water level and this is a downstream water level. This is upstream bed and this is going to be downstream bed, and beneath this, what is this? Soil mass. Here, this is a gravity dam. Sir, why you are taking only gravity dam? Can't you take the earth dam? Yes, I'll take, but I'll explain you in the next chapter, C-base analysis. But as of now you see the difference between these two water levels. What is this difference between two water levels? Whatever the difference between the water levels, so let me take this as a capital H because I am taking the total condition, right? So far I am using a small h, right? So now I am going to take the capital H. What is this capital H, sir? This is total hydraulic or C-base head. Total hydraulic or C-base head. Now you say, you know that flow will not happen through the dam. Now the flow is going to be starts beneath the dam. So from where it is going to be start? You observe. This is the point where the flow is going to be start. Yes. So now when the start is going to be, when the flow is going to be start, at first it is going to be a horizontal, means vertical downward C-base. So now I am here. The person is here. And what is the energy? With what energy I am going to travel? H. With what energy I am going to travel? H. So what is the meaning of the H? I am telling you the definition of head every time. The energy, I am here, the energy that are required to travel from this point to this point is the hydraulic head. So I want to travel from here to here. So I will travel. When I travel, I require this much amount of the energy as a minimum. Now, when you start to travel, by the time you reach over here, definitely you are going to lose some amount of energy or not? Yes. So now when I reach this point, at this point, the same me. So initially my energy is going to be H. By the time I reach over here, definitely I will lose some of my energy, which means when there is a flow, there is a head loss. So let's take this as 0.7 H. There is an example I am telling you. So don't ask me that, sir, why you are taking only 0.7 H. I will take 0.5 H. It's up to you, Nana. So I am taking an example of 0.7 H. Now I proceeded further. When I proceeded further, let's say by the time I reach over here, now again by the time I reach over here, so this time my energy would be much more lesser. So my energy is going to be, let's say, I have 0.3 H. So now from here onwards, this water level will start to move upward. And by the time I reaches over here, I'll be fall down like this. So because my energy is going to be 0. So what is the minimum energy I have over here? The energy I have over here is going to be 0. So I start with the energy of a seepage head H, and as I travel, I lost the energy as 0.7 H. So what is the meaning of H to 0.7 H? You lost 30% of energy, which means from here to here, you have done 30% of work. Now, from here to here, now initially H, and by the time I reach over here, what is my head over here? 0.3 H. What is my head over here? 0.3 H. So the seepage head at this point is going to be 0.3 H. What is the meaning of seepage head at this point? 0.3 H, which means I lost 70% of energy by the time I reach over here. So 70% of energy means I have done 70% of work or not. And by the time I reach over here, I don't have any other energy. So now let's take this as a datum line, a reference line, which is at a depth of Z below the ground level. So below the ground level. Now you tell me, first of all, is it a downward seepage or upward seepage? So as it is going to be a downward seepage, you know that always the submerged pressure acts downward, gamma dash into Z. Here also the submerged pressure acts downward, gamma dash into Z. But in the case of the downward seepage, as the seepage is downward, the pressure acting due to seepage also acts downward. So you know that here the pressure is going to be gamma W into H. But by the time you come over here on the downstream side, this is upward seepage. As it is upward seepage, you know, this is nothing but gamma W into H. So now can you please tell me what is the H value over here? This is Hx and this is Hs of x. I told you clearly again and again. Now I'm representing both. So you see gamma W into H. Here the H means from here to here you have done work. How much energy you have done? 30%. So then what is the H over here? 30%. What is the C base head that you have utilized over here? 30% of H, 0.3 H. Now this is the point where I am going to start the upward C phase. So when I start the upward C phase, I have to travel a length of how much? Z. And in order to travel this, what is the energy I have? 0.3 H. By the time I reach over here, what is the energy I have? 0. And when I travel a total length of Z, what is the head loss? 0.3 H. And what is the energy required to create the upward C phase is known as a C phase head. So here, this H is going to be 0.3 H. So now, what happens due to this C phase? As you observe, the meaning of effective stress. What is effective stress? Effective stress means contact or effective or intergranular pressure. Intergranular pressure. So the meaning of effective stress is when there is a contact between the particles, there is effective stress. You observe in the case of the downward C phase, this is plus. And in the case of the upward C phase, effective stress is going to be gamma dash into Z minus gamma W into H. So my question for you, which one is going to be cause a failure to the soil mass? Does effective stress is a advantage or disadvantage? Advantage. I told you effective stress improves the strength of the soil mass. Yes. So effective stress means a stress transferred from one grain to another grain. Stress transferred from one grain to another grain, that is going to be the effective stress. Okay. So now if you observe, when the contact between the particles is less, then effective stress is going to be less. Then the strength of the soil is going to be less. In the case of the downward C phase, the effective stress is going to be increases, but in the upward C phase, effective stress is going to be decreases. In a upward C phase, effective stress is going to be decreases. So now in upward C phase, when the upward C phase pressure becomes equals to submerged pressure, when these two are going to be same, then effective stress becomes 0. When effective stress becomes 0, then the contact between the particles is going to be 0. When the contact between the particles are 0, then when there is no contact, then the soil will be in which state? Liquid state. Then cohesionless soils loses its all strength and behaves like a liquid. Such a type of condition is known as quicksand condition. So now what I'm going to say, the condition is quicksand condition. Quicksand condition. What is this quicksand condition, sir? What is this quicksand condition? Quicksand condition means in upward C phase, you see the C phase on the downstream side. See, this is our downstream side and this is upstream side. On the downstream side, so in upward C phase, when C phase pressure, what is the C phase pressure? Gamma W into H. Equals to submerged pressure. Equals to submerged pressure. So what is the submerged pressure here? The submerged pressure means gamma dash into Z. Gamma dash into Z. Then effective stress becomes 0. Effective stress becomes 0. Effective stress is going to be 0. Now, at this condition, At this condition, cohesionless soils loses its salt strength and behaves like a liquid. And behaves like a liquid. Such a phenomena is known as quicksand condition. Such a phenomena is known as quicksand condition. So, in the case of the upward seepage, when upward pressure and downward pressure, submerged pressure are going to be same, then effective stress becomes zero. And at this condition, the cohesionless soils loses its salt strength. Mind it, I am taking the cohesionless soil. Sir, why you are taking only the cohesionless soil, sir? Sir, the shear strength of a soil for shear strength of soil, let's represent with the S. This shear strength is equals to C dash plus sigma dash into tan phi dash. Sir, how you got this relation? I am going to discuss this relation in chapter number 13. So in that chapter number 13 there, I am going to explain you how this one has appeared also. So wait for up to that moment. So don't worry, as of now, you please remember this equation. But in chapter number 13, there is a shear strength chapter. I am going to explain you clearly whether you are going to get what is the meaning of this shear strength and all those things. So where S is a shear strength and C is cohesion and phi is internal friction angle. Sir, what is the meaning of this dash? Sir, dash represents effective cohesion and effective friction. You know that for cohesionless soils, C dash is going to be 0, and when effective stress also becomes 0, when effective stress becomes 0, now you tell me what is S? C dash plus sigma dash into tan phi dash. As you know, the C dash is 0 and sigma dash is 0, then the shear strength of the soil is going to be 0. And when the shear strength of the soil is going to be 0, then soil behaves like a liquid. Such a phenomena is known as a quicksand condition. So mind it, such a phenomena is known as quicksand condition. Sir, how come we find out whether there is a quicksand condition or not, sir? How come we find out whether there is a quicksand condition or not? So for that, as an engineer, we always say, see, when you design a structure, see, I designed this dam. When we design this dam, we do provide a factor of safety. Yes. So what is meant by factor of safety? Factor of safety is so when factor of safety greater than 1, we say it as safe. When the factor of safety is less than 1, we say it as fail. And when factor of safety is equals to 1, we say it as critical. So what is meant by that factor of safety? If you know the factor of safety, then we can say the condition. Now, what is this factor of safety? It's not the end. The quicksand condition is not the end. Factor of safety. Represented with F. So the factor of safety, F is equals to resisting by causing. See, this is the basic definition of the factor of safety, because if you want to make sure anything to be safe, always the resisting forces or stresses or moments. I can say force, or I can say stress, or I can say moments. Anything you take here, the resisting should be more than the causing. Then only the factor of safety is greater than 1. Then you can say it as a safe. So now, in the case of the seepage, what is the resisting, what is causing? You please look over here. Which one is resisting here and which one is causing? See, do you think the quicksand condition occurs on the upstream side? No. Do you think quicksand condition appears on the upstream side? No, it will occur only on the downstream side with an upward seepage. So here the factor of safety is known as downward pressure by upward pressure. So what is the factor of safety? What is the downward pressure here? Gamma dash into Z, or okay, fine. Let's take this a factor of safety aside. So I'll tell you this factor of safety. Now, whenever the factor of safety is going to be, when factor of safety is equals to 1, then we can say it as a critical condition, which means downward is equals to upward. When factor of safety greater than 1, we can say it as safe. And when factor of safety is less than 1, we say it as a fail. So now, yet a critical condition yet critical condition, downward pressure is equals to upward pressure. So what is the downward pressure here? Gamma dash into Z, and upward is going to be gamma W into H. Gamma dash into Z is equals to gamma W into H. So now you tell me, where do you see the quicksand condition? Quicksand condition occurs at a critical condition. Yet critical condition, you can see the quicksand condition. So because in the case of the quicksand condition, when above, downward, and below, upward, both are same, then effective stress becomes 0. Then the quicksand condition attains in the case of the corrosionless soils. So gamma dash into Z is equals to gamma W into H. So now I can write H by Z is equals to gamma dash by gamma W into, sorry, gamma dash by gamma W. So what is this H by Z, sir? See, H from here to here, what is the head required per unit length, which is nothing but hydraulic gradient R naught. So as I discussed about the critical state, now this is I. As I discuss about critical state, then it is going to be critical hydraulic gradient. IC is equals to gamma dash by gamma W. So what is this gamma dash? You know that gamma dash means gamma sat minus gamma W. So gamma dash by gamma W means gamma sat by gamma W minus 1. So what is gamma sat by gamma W? G plus E by 1 plus E minus 1. So now if you solve this one, I'm just showing the procedure over here. So this time up, but please wait for a few minutes, some 5 to 10 minutes, because we'll be wind up this. If we stop over here, it will be somewhere in between. So please wait for 5 to 10 minutes so we can finish this thing. So now IC, yes. So from this I can write IC is equals to gamma dash by gamma W. So now if you see, IC is going to be written as G minus 1 by 1 plus E. G minus 1 by 1 plus E, or we can written as G minus 1 into 1 minus N. See, if you apply the conditions, above conditions, we are going to end up with this relation. So you please go through this relation once again. This IC, where IC is critical hydraulic gradient. IC is critical hydraulic gradient, and it depends on soil property G comma E. You see over here, whatever the soil, it must be having some specific gravity and void ratio, right? So for the given soil mass, definitely there is one G value and for a E value. Then the critical hydraulic gradient depends upon G comma E. Sir, how come this relation came, sir? Sir, you know the relation between the void ratio and porosity. You please apply over here. You will be end up with this equation. So IC is equals to G minus 1 by 1 plus C. And generally, IC value is almost equals to 1. IC value is almost equals to 1. So at a critical condition, when downward pressure and upward pressure both are same, then you know that factor of safety is equals to 1. Then you can say the gradient as a hydraulic gradient IC. So now when IC is equals to 1, then what is the factor of safety? So I hope you understood the critical hydraulic gradient over here. Now coming to the factor of safety. What is the downward pressure? The downward pressure is gamma dash into Z by gamma W into H. So I can write this one as gamma dash by gamma W by H by Z. Can we write this one? And now you see, just now we explained that gamma dash by gamma W is represents IC by H by Z means normal hydraulic gradient. So now when the factor of safety is equals to IC by I, you see, based upon these equations, number one, factor of safety IC by I, and IC is equals to G minus 1 by G minus 1 by 1 plus C. There are n number of previous GATE and IS questions have been asked. In this chapter, if you want to remember any formula, you need to remember the formula as IC is equals to G minus 1 by 1 plus C. Factor of safety is equals to IC by I. So these are the very important formulas in this chapter. And if you go for the previous ESC questions, most of the questions, I say 80% of the questions have been appeared based upon these two formulas in this chapter. So they are very, very important. So now, sir, if I apply some surcharge on the downstream side, you observe here, please. Yes, here N is going to be porosity. Here N means porosity, Nana. So E means void ratio and N means porosity. So now, if you see, if a surcharge of intensity Q is applied on downstream side of dam, downstream bed. You see, I'm not drawing the full figure. If this is a downstream, this is a downstream bed. So now where you are going to look over the seepage. I hope you remember this point. See, I am taking this, I am zooming this portion only. So now, if I would have applied some surcharge of intensity Q, then you please tell me, see, this is Z. According to surcharge in previous chapter, chapter number 7, due to surcharge, the increase in vertical stress at any depth is going to be seen. So here, already gamma dash into Z is there. Now, due to surcharge, again one more pressure came, Q. And what is upward? Gamma W into H. So what is the final factor of safety here? So final factor of safety here is, now you cannot remember it as IC by I. So what is the final factor of safety? Gamma dash into Z plus Q by gamma W into H. So these are the equations. When there is a surcharge, then you have to go through this one. And if there is no surcharge, then generally the equation is going to be IC by I. So if there is a surcharge, they will mention you clearly. So don't worry about that. But let's come to the quicksand condition again. So as I told you, whenever the critical condition attains, when downward pressure equals to upward pressure, factor of safety is equals to 1, then the quicksand condition comes into the existence. Mind it, quicksand is a type of condition. It's not a type of sand. Don't think the quicksand is going to be a type of soil. Quicksand is a type of condition, but not type of soil. Quicksand condition occurs in fine sands and silts only. Fine sands and silts only. Sir, why not for clays and gravel, sir? In clays, due to cohesion, soil will not behave as liquid. Soil will not behave as a liquid because S is equals to C dash. You please go back and have a look over here. In the case of clays or cohesive soil, C is there. Then shear strength will not become 0. When the shear strength is not going to be 0, then the soil will not behave like a liquid. Then what about the gravels? For gravels and coarse sand, due to high permeability, tile water level would be more. Results in less difference in water levels and less hydraulic head and less makes less upward, or I can write as simply less seepage pressure. So in the case of the gravels and sands, you observe this point. I am giving you all the explanations over here. For gravels and sands, you know the permeability of the soil is very high. So now let's get back to this condition. If it is a gravel, let's take, it has some permeability, K. And if the permeability of the soil is more, then this soil will allow more water. When the soil will allow more water, then the tile water level, you see this is nothing but tile water or not? Yes. So if the permeability is more, then the tile water level is going to be rises. When the tile water level rises, the difference between the water levels is going to be decreases. When tile water rises, the difference decreases so that the total hydraulic head will decrease. When the head is going to be less, then the seepage pressure is going to be less. When the seepage pressure is going to be less, then the downward is more. Upward is less. Sir, upward is less. But you see, in the case of gravel, the denseness is going to be more or not. So in gravels, submerged pressure is going to be more and seepage pressure is going to be less. So when one pressure is more, other is less, there is no possibility the both are going to be same. That is the reason why this quicksand condition will occur only in the case of fine sands and silts. Their permeability is less and they does not have any cohesion. Then only quicksand condition is going to be attained. So in one of the previous ESC question, quicksand condition occurs in what type of soils? Fine sands and silts, sand, silt, clay, gravel and sand, and all of the above. Quicksand condition occurs only in the case of fine sands and seeds. So that's about the quicksand condition. And the last point over here is yet a quicker condition. The sand water mixture so has density as twice of density of water. Example, marshy lands. I hope you remember these marshy lands are in Hindi. We can call it as daldal in Hindi. See, what is this marshy land, sir? I hope in most of the old movies, especially at the climax, so usually the villain used to fall in a small soil pit, and so while he wants to coming up, so he's going to be dragged or pulling downwards, and he's going to be dying. Such type of pits, that are soil pits, are known as the marshy lands. I hope you came across this one in videos, or I hope you have seen in the movies also. So such type of pits are going to be marshy lands. So, and especially the Telugu people or North people also, you might have seen this movie Magadira. In Magadira movie, there was one scene where the hero was chasing a villain. So at some point of time, the hero means there comes a situation where the hero's a horse and the hero is going to be pulled down into the soil mass. But actually, that is a dry sand over there. That condition is different. But if that if that sand is going to be wet, such a type of condition is known as a quicksand condition. So when the quicksand condition comes into the existence, it seems like a soil only in wet state. But when you fall into such type of soils, this sand mixture has a density which is twice of the water, so it will pull you down. So such type of example is the marshy lands. If you want to see any video, you please go through the YouTube. You can just check on the marshy lands. So there are a lot of documentaries were made. You please go through that. And this quicksand condition is also known as boiling condition. Boiling condition. So you can observe some boilers like you see some boiling type. You observe this one. This is a ground level. So whatever this area, you can observe this is going to be the person. So when a person falls into here, he cannot come out. He cannot come out. So when a person falls into such type of areas, he cannot come out. Even if you try to help also, even if you pull him up also, you can pull him half of his portion, but he cannot come out. So that's about the quicksand condition. Now, how this quicksand condition is going to be affect the dam? What are the type of failure we are going to see? And that failure is known as a piping failure. And we will be seeing that piping failure in tomorrow's session. So I'll be stopping the class with this, and I'll take us some doubt session of 15-20 minutes. So meanwhile, a lot of people have said, sir, time up. So quicksand is different from liquefaction of sand. Yes, the quicksand is going to be different from the liquefaction. We will be discussing the liquefaction in chapter number 13, shear strength. So don't worry about that. So now that's about the today's session. So now those who wants to leave, they can leave. And I'm going to enable the so I am enabling the rise of hand option. So meanwhile, a lot of questions also have came. So let's see some of the questions. So I'm going to explain the questions which are legitimate. Some students they are much more focused on the timings than the subject. So I hope The persons who are commenting over here, sir, time up. I hope the same way you're concerning and focusing towards the subject also. Yes. The time means, see, tomorrow I'll be discussing also. Sorry, I did not have a time to discuss about the great preparation strategy, but I'll be posting a video today. So I'll be posting a small video, and in that video I'll be explaining by today evening or today night. So most probably I'll post a video. Else I'll take that one session as a 15 to 20 minutes tomorrow, how to prepare for the gate effectively. But as we are focusing more towards the concept over here, I did not saw the time, so we'll discuss it tomorrow. Don't worry about that. Very good. See, in Man vs. Wild, Bear Grylls, I have seen this documentary also in Discovery Channel. So you means you can go through that. You can go through the YouTube channel also. There you can see Man vs. Wild, Bear Grylls. There he was explained the quicksand condition. So I thought of sharing that video, but it was available in Netflix, in Geo TV also. But while I was screen recording that, it was not came. But the people who are having are the people who are using the Geo mobiles or Geo SIMs. So you can have an access over the Geo TV. You can watch over the Man vs. Wild by Bear Grylls. There he has explained the quicksand condition also. Sir, your preparation strategy, I will tell you, Nana, because most of the people has gone already. As I have patience, but the people who are standing and sitting over there, they did not have patience. So I'll tell you. Definitely, I'll tell you tomorrow the preparation strategy. I'll be sharing with you tomorrow, definitely. Hare Baba, some of the students, sir, you explained volumetric shrinkage ratio, and degree of shrinkage, but not shrinkage index. So please go through the indices. After the plasticity index, I have discussed the shrinkage index. So due to some technical issues, I missed the today class. So please upload class video by today. See, today only it will be uploaded, and meanwhile, you please go through the notes once again. So I'll be uploading the notes once the class done. Every day I'm uploading within 10 to 15 minutes of the class, after the class, or before 2 o'clock or before 2 p.m. The PDF will be available in the website. So you please go through that and you please download that. Okay. So now let's see the students who have raised their hands. Mr. Pramod, you can speak now. Yeah, Pramod.
Sir, there is one question from ESC 2014.
Which chapter?
Chapter number permeability, sorry, effective hysteresis.
In ESC or GATE?
ESC 2014.
ESC 2014 permeability chapter.
Yes, sir.
Permeability or effective stress?
Actually, sir, effective stress, sir.
2014. Yeah, the void ratio of a given soil is that. That is the question you're saying?
Yes, sir. Soil A and soil B. They have
is twice of the soil B. While the effective size of particles is 1/3 of that soil B. The ratio of height of capillary rise. Yes. What's the problem with that?
Yes, yes. Sir, how we can apply this void ratios value in
Baba, you please go through the notes. I have given the capillary rise. The capillary height HC is equals to 0.3 by E into D10, right?
Okay.
You get the relation. HC is inversely proportional to E into D10. You please go through that relation. You will get the answer. Okay.
Okay. Sir, second one is that from 2015.
In the same chapter?
Yes, sir.
2000.
They have given two statements actually.
Yes, effective stress in a sand layer below a lake with a standing water does not alter as the, yes, effective stress in a sand layer below a lake. Below a lake, whatever the water fluctuations, effective stress does not alter. State number one is true. And regarding water table below the ground surface, any rise in water table causes equal changes in both the pore pressure and effective stress. No. See, second statement is below the ground table. Sorry, below the ground level. Below the ground surface, if water table rises, pore water pressure increase and total stress increase, but they won't increase in the same magnitude. You please go to the conclusions I have mentioned you. So I gave a box over there. I made 3 conclusions. So statement number 2 is false. And capillary saturation will cause the effective stress increase. Yes, it is going to be increased. So the answer is going to be 1 and 3 only. That option should be. The option should be, see, the correct option should be D. It's not going to be A. You please correct it. Hello, Mr. Pramod? Mr. Pramod? Mr. Pramod? I hope you were able to listen, but so Mr. Pramod, the correct answer for question number 9. Yes, the correct answer for question number 9 is D. 1 and 3 only. Please go through that once again. So now, I'm seeing no new ones every day. I'm having the people who are raising their hands every day. They are the ones who are rising every time. So, Mr. Aditya, Sai Krishna Aditya, please speak out.
Hello.
Yeah, Mr. Sai Krishna Aditya, please speak out.
Sir, am I audible, sir?
Yeah, you're audible to me.
Sir, I have doubt in ESC previous chapter number 7, sir. Question number 11.
So just now I was explaining that.
Question number 11, sir.
Question number 11.
Yes, sir.
Okay, tell me now.
Sir, in this, sir,
average grain size. Average grain size means D10.
Yes, sir.
0.03 mm. The size of the interstices is 1/8 of the mean grain size. Means the size of interstices means a die of wide.
Yes, sir.
1/8. Considering
yes,
sigma of water as 0.07 gram per centimeters. Actually, in this question there is no correct answer.
8 is answer, no, sir?
Yeah, answer should be 8, but there is no
yes,
correct answer at that point of time. So the solution that we have provided, they have given the answer also.
Okay, sir. Yeah, that was the doubts. Sir, in chapter number 5, 12th question.
Yeah.
Chapter number 5, 12th question.
Yes, chapter number 5, 12th question. Okay, 12th question. Which one of the following statement is correct? Yes?
Sir, in this option B should be correct, no, sir?
Grain size is a primary criterion for classification of coarse grain soil. Yes?
Sir, option is given as A, sir.
Which one of the following statement is correct?
Yes, sir.
Okay. Fine. Sorry. Means grain size is a primary criterion for classification of coarse as well as fine grain. See,
sir, fine grain we use plasticity, no, sir?
No. We have used the sieve analysis also, right?
But we means in that
primarily we depend. See, primarily if they ask a question like fine grain soils are classified more of plasticity characteristics than sieve characteristics, then that is correct.
Okay, sir.
But
means
initially
we are using this sieve analysis, so we have to take that into consideration.
Yeah. So why we are not using sieve analysis more is the sieve analysis is long time taking and it's quite expensive also.
Yes, sir.
So, but you can use both. So
yes.
If there is a condition of plasticity characteristics and sieve analysis, then you go for a plasticity characteristics. Okay.
Okay, sir. Thank you, sir.
Yeah.
That's it, sir. Thank you.
Mr. Ash, speak out, please. Mr. Ash, speak out. Mr. S. Okay, fine. I'll be going for the Mr. Damodar Rao. Mr. Damodar Rao, please speak out.
Hello, sir. Good afternoon.
Yeah, Mr. Damodar Rao, tell me.
Sir, I have a doubt regarding previous gate, chapter number 6, question number 6. 1 mark.
Previous gate, chapter number 6, question number 6. Chapter number 6. We have a good once. Chapter number 6, question number 6. That is see, in the question typo, there is a
Okay.
mistake in the typo, so don't worry about that. That was typo there. It has not been erased. So means this year in the edition we are going to. So don't worry about that. Okay.
Okay. Thank you, sir.
Yeah. Okay. Mr. Sai Krishna. Miss Aparna. Miss Aparna, please speak out. Miss Aparna, please speak out. Miss Monica. Miss Monica, please speak out.
Hello, sir.
Yeah. Hello. Tell me.
Sir, in case of quicksand condition,
Yes.
if the soil is coarse grain, you told permeability is high,
Yes.
but will the weight of coarse grain resist the seepage, sir?
Yes. Downward is going to be more. Submerged pressure is more, and at the same time, upward pressure, seepage pressure is less. Both are going to be there.
Okay, sir.
Weight of the gravel, the resisting force is more. Okay.
Yes, sir.
Due to more permeability, seepage pressure is less.
Yes, sir.
Okay. Fine.
Thank you.
Mr. Pawan Kumar. Mr. Pawan Kumar, please speak out.
గుడ్ ఆఫ్టర్నూన్ సార్.
Yeah. Good afternoon, Pawan.
సార్ నా డౌట్ వచ్చేసి ఈఎస్సి చాప్టర్ 6 సార్.
Chapter?
చాప్టర్ 6 పర్మియబిలిటీ.
Yes. ESC chapter number 6. Come on, tell me.
సార్ అందులో ఒక నిమిషం సార్, అందులో 22 క్వశ్చన్స్ చేయండి సార్.
Question number 22.
ఎస్ సార్.
Just tell me. See, they
Sir,
have the drawdown means head loss 2 meters.
Yes, sir.
You have to take per
Yes,
unit meter. They did not give the length of the seepage, so you have to take
Yes, sir.
Okay.
ఓకే సార్. సార్ ఆన్సర్ సి సార్. ఏ రాంగ్ సార్.
See, you have to take the I value as h by l. H by l means 2 by 1. So
Yes, sir.
obtained is for 20. They have given the quotient of permeability Q Kia
Yes, sir.
0.001 into 20 into 2. 40
Yes,
into
sir.
point.
ఆన్సర్ సి సార్. 1200.
They have given in terms of liter per minute, right?
ఎస్ సార్. కన్వర్టెడ్ ఇంటూ
Solving, you got what is the answer you got?
1200.
1200? No, I don't think so.
Yes, sir.
Correct answer. No, yeah. You please convert that into units, right? See, if I directly convert that to 0.001 into 20 into 2, that's going to be 40 into 0.001 meter cube per second. Then
Yes,
if you convert into liters, then 40 liters per second. And if you convert into second minutes, 40 into 60, that is going to be 2400. So you please you please go through the calculation. So the answer is 2400 only. It's not 1200 LPM. Okay.
ఓకే ఓకే సార్. ఇంకో క్వశ్చన్ సార్.
Tell me.
సో సార్ క్వశ్చన్ నెంబర్ 3 సార్. క్వశ్చన్ నెంబర్ 3.
Question number 3 in
అదే చాప్టర్ సార్. 6th చాప్టర్.
question number 3. Okay, what happened? Ratio of the permeability in the bed in the horizontal to the vertical direction. This type of question I have given you in the in assignment also. Ask
ఓకే ఓకే
kx by ky. Horizontal direction means
Yes.
flow parallel to bedding planes, vertical flow
Yes,
perpendicular
sir.
to planes.
Yes, sir.
So what's the problem then?
సార్ ఇక్కడ 2.8 ఆన్సర్ వచ్చింది సార్ చేసినా కానీ అది 2.8 to 1 మిడిల్ అంటే అది అర్థం కాలేదు సార్ ఆన్సర్.
2.8 అంటే మీనింగ్ ఏంటి? 2.8 by 1 రేషియో. ఓకే
ఓకే ఓకే సార్. ఓకే సార్.
ఫైన్. ఓకే పవన్.
ఓకే థ్యాంక్ యూ సార్.
Okay, fine. Now let's see. Miss Aparna again. Miss Aparna, please speak out. Hello.
Good afternoon, sir.
Good afternoon, Aparna.
I have doubt regarding previous grade question, sir.
Which chapter?
Chapter number 5, 5th chapter.
Okay.
In the 2 marks question, second one, sir.
Chapter number 5. Two marks question, second one.
Third one, classification of the soil.
Okay, so this.
How can we find out D30, sir?
Well, you don't need to find out anything because you see whatever the sieve sizes are they are presenting over there. You place look over sieve sizes. 600 micrometer.
500 micrometer.
And then
425.
yeah, all the sieve sizes are less than 4.75 mm.
Yes, sir.
More than 75 micrometer.
Codes grains.
All the sieve sizes are less than 75 less than 4.75 mm and more than 75 micrometers. Yes or no?
Yes, sir.
So what is the soil that present between these two sieves? Sand, right?
Yes.
We can say the soil mass is sand.
Yes.
And you got Cu, right? What is Cu value? What is Cu? What? 1.2, right?
Yes, sir. 1.2. Cu.
If you know Cu and Cc, if any one of those two is out of range, you can say it as poorly graded or not.
Yes, sir.
Already Cu is less than 6. As we know, soil is sand. When Cu greater than 6, then it is well graded. Yes or no?
Okay.
As the Cu itself is less than 6, then you don't need to go for Cc value. So as
Poorly graded, sir.
poorly graded, soil is sand, poorly graded sand. Got it?
Okay, sir. Another doubt, sir. In 6th chapter,
Tell me.
7th question.
6th chapter, 7th question. See, this is a small problem with that 7th question. I'll be discuss that later. So, I'll be writing that solution and I'll be sending you people. Okay.
Second question also.
Huh?
Second question.
Second question, 2 marks.
2 marks.
For what type of soils would we use the falling head and constant head?
Sir.
Huh?
Next one.
In a falling head permeable test, the initial head 1 meter drop to 0.5. The test, that one only?
No, sir. Estimate the flow quantity through the soil.
Which question I'm not seeing? Sixth chapter only, right?
6th chapter only, sir.
Sixth chapter and which question you are saying?
Second question.
2 marks, second question. So let me check.
Estimate the flow quantity through the soil. Sir, they didn't give figure.
Oh, okay. In that second part, okay. So estimate the flow quantity in liters per second through the soil in the pipe shown below. Okay. Pressure head 2 locations are shown in the figure. The internal diameter of the pipe is 1 meter. Okay. Figure is missing, right?
Figure is missing. Yes, sir.
Yes. So let me have a check once.
Sir, 8th question. In that chapter only, 1 mark question. 8th one.
So the figure is missing. I'll be letting you know that figure for you. Okay, fine.
Yes, sir.
I don't think that the figure requires. Okay, yes, the pressure head is required now. I value is required. So fine. So which question now?
8th one.
8th one. Yeah. What happens between the eighth one? Two are soil specimens with identical geometry dimensions.
No,
Identical
sir.
geometry. Huh?
1 mark.
1 mark, eighth question. That is in chapter number 9. In chapter number 9, next chapter we are going to see the flow nets. There we will get. Okay.
Okay, sir. Thank you, sir.
Okay, Aparna, bye. So today's last call, as it's already 1:40. So the people who are having doubts, you people can message me, means through mail. So Mr. Sahasra, please speak out.
Hello, good afternoon, sir.
Yeah, Ms. Sahasra.
Sir, my doubt is from previous grade, sir.
Yeah, which chapter, which question?
5th chapter, 1 mark, 7th question, sir.
5th chapter, 1 mark, 7th question. 5th chapter, 1 mark, 7th question. The value of liquid limit and plastic indices. So
Yes.
I told you in the class, means while I was discussing in doubt clearing session also. Fine. See, one point. If all the soils are from the same origin, if you plot their liquid limit and plasticity index, as liquid limit increases, plasticity index also increases. Yes or no?
Yes, sir.
So if you draw all those points and if you draw a line, then line is going to be exactly parallel to a line.
Okay, sir.
Whether that line may lie above the a line or below the a line, forget about that. Okay.
Okay.
Just to draw those points, and if you draw a line along that, then it is going to be a line. So you see, I'm writing over here. You know, this is a line, right?
Yes, sir.
If I take some origin, some side, so soil A, soil B, some soil C. So if I take 3 different soils, if I plot these liquid limit and plastic limit over here, so for soil A, it might be here. So this may be soil C and this may be soil B. If you join all those points, then this line is going to be exactly parallel to the A line or not? Understood?
Sir, but their liquid limits might be different, right, sir?
So liquid limit might be different. Yes, this is liquid limit and their IP is also going to be different, right? This is WLA and this is a different liquid limit. This is different liquid limit. Different liquid limit, different plasticity index. Okay.
Okay, sir. Thank you, sir. Thank you, sir.
So today I'm going to stop the sessions, doubt sessions. So it's already 1:40. And then still the people who are having it out, you please mail to me and we'll see remaining things. But you people please go through the previous videos and PDFs. You have to make sure you understand all these concepts clearly. So for today I am leaving the session. So